Hey there, welcome to this video on Spring Framework. Now in this particular video, we are going to learn a lot of concepts that will help us understand the underlying principles of Spring Framework. And these concepts will set the right base to learn advanced topics in Spring Boot and topics like microservices. If you ever want to transition into these fields, then understanding these underlying concepts is really important. Okay, so here is what we are going to cover. We're going to talk about, and we are going to do an introduction first of all to Spring Framework, and we are going to also understand this term called Web Framework. Well, if you are aware of what Web Framework is, feel free to skip to the next chapter or next lecture. I have a detailed timestamps added in the description section of this particular video. Okay, now timestamps are added for this particular purpose, wherein if you don't want to learn like what is, or you don't want to listen to what is Web Framework, you're already aware of that, you can straight away jump over to the relevant topics that interest you. But I would say it would be a good refresher. If you go through, you might hear or learn something new over here which you didn't knew before. Okay, so going in sequence is advisable always, but if you are in hurry and short on time is really precious, by the way. So you can directly jump over to the relevant sections. Okay, so we are going to talk about what is Web Framework. We're going to do an introduction to Spring Framework, and we're going to talk about the core concepts around Spring. Then we're going to discuss tight coupling versus loose coupling. Now, what is tight coupling? Why these concepts matter? Okay, and of course, I'm not just going to explain the theory part over here, but I'm going to go hands-on in the coding editor, and I'm going to create scenarios with tight coupling, loose coupling, and I'm going to show you the differences between them. So the knowledge you gain over here is going to be knowledge for life, because I'm not going to teach you, I'm going to help you understand. And when you do things, when you see things happen in coding editor, okay, and not in slides, okay, when you see things happen in the coding editor, you understand things. Okay, so that is what I believe, and that's my style of teaching. If you have been following me for a while now, so I prefer coding editor to explain concepts. Yes, I make use of slides, okay, but coding editor is, I think, is the best way to teach something. Okay, so I'm going to teach hands-on tight coupling and loose coupling. We're going to talk about some core concepts of Spring Framework, like I mentioned here at the top. Okay, then I'm going to talk about Spring Container and configuration. So what is Spring Container? How can you set up a Spring Boot project? We're going to talk about beans and dependency management, like creating your first bean, lifecycle of a bean. Okay, dependency injection. Now, what is dependency injection? Like constructor injection, setter injection, and how can you make this happen? So these concepts are important. Okay, they form the core of Spring. Advanced dependency management. So how can you, what is inversion of control? So understanding inversion of control. Introduction to autowiring. What is autowiring, and what are different types, like autowiring by name, type, and constructor. So I'm going to explain all of this. Okay, I'll get rid of this challenge. Okay, I'm going to explain all of this to you all, and why learn these Spring concepts first of all. Okay, so this is one of the things that a lot of you might have. Okay, but I want to address these over here. Okay, so number one thing is basically, if you are like, the reason you should learn Spring Framework concepts is it helps you understand the underlying principles of Spring. Okay, and you know, you can directly learn Spring Boot if you know Java, but there are some concepts that help you, okay, in the longer run. So like, if you understand the underlying principles of Spring, then you can handle edge cases better in any sort of real world projects. And if there are any specific configuration modifications that you need to do in your real world project, okay, as per your client requirements, then in that case you can do it better, because you understand the underlying principles. You understand how things are happening behind the scenes. So these really help, okay, in the longer run, if you are willing to transition into a serious developer. This also helps in transitioning smoothly into advanced topics like microservices. And if there is any sort of errors, which we always get, okay, as a developer, you'll always get errors. Like, you can't say I'm writing error-free or bug-free code. So it helps you with debugging and customizations as well. So yes, this is what we are going to cover. Now, without a further ado, I'm going to jump right in to the learning part. Okay, but I would like to mention over here, like if you have been following me for a while, or if you're new to this channel and if you haven't liked, subscribed yet, you should definitely do so, and comment below and let me know what you think of this course and what sort of new content I should bring to you all. All right, and that's it. I shall see you soon. Thank you. Hello everybody. Let's start talking about what is a web framework. So first, let's get into the specifics of why do you need a web framework. So if you look at most of the web applications that exist today, they have a lot of things common in them. For example, all web applications need to serve the web page when a user tries to access a certain URL. All web application needs to have the aspect of security. All web applications need to have databases, authentication, and so on. So there are lots of common elements that exist in the different web applications that exist today. So these are just the standard list of things that I mentioned over here. But the question is, should you build this thing as a developer every time when you build an application right from scratch? So think of this as building a house. So if you build a house, you would need some blueprints and tools, okay? And for web development also, that is how things work. So you need set of tools, like some set of pre-built things that you would be incorporating in your web application, and developers earlier had to build these things right from scratch. Okay, so if you have to build a web application in Java, you have to manage things like security, authentication, and everything, like how a URL is accessed and all these things manually. So this was the case early on. Okay, and this was written manually by the developers every time they create a new web application. There was no boilerplate or a starter template that they could use. And this was very effort taking and is required by almost every website out there. Like, developers cannot say no to this. Okay, so you can compare this with the analogy of building the house. Okay, what if you had a set of tools, a blueprint ready? Okay, because every house needs that. Okay, they would need certain tools, they would need some sort of a blueprint to set up things quickly. And that is where web framework comes into picture. So what if I would tell you that you could have some prefabricated components that you could use, okay, and you could just use these prefabricated components that you could assemble to make a house with fewer errors, a lot more faster. So by prefabricated components, I mean pre-built walls, doors, windows, and so on. Okay. Now, you could assemble these faster. Yes, right? Like if you could get a list of prefabricated components, you could put them all together really, really fast. And you could also reduce the number of errors that you would get during the process. So this would make the entire process a lot more easier, faster, and you could focus on important things rather than doing repetitive things. And of course, this would make you fast. Now, this is what a web framework does. So what is a web framework? So web framework is nothing but a collection of tools and modules that is needed to do standard tasks that are required across every web application. Okay. So web framework consists of some standards. Like for example, every website needs to serve web pages, interact with the database. They also need to interact with the web host. And hence, web framework take away these repetitive tasks and have a standard defined which you as a developer can follow and use that as a starting point. So rather than creating a blank new file when you start creating a web application, okay, you can use something called as web framework, which has some set of things already pre-configured. And this makes you a lot more faster. The benefit of this is you get to focus on important things rather than focusing on or doing a lot of repetitive things. For example, you can focus on business logic rather than setting up things and the boilerplate code. So that is what web framework is, and it makes your life a lot more easier. So you can compare this with the analogy of house building. So if you could have pre-built house, like a pre-built wall, pre-built windows and so on. Like windows you would need for every house, right? You would need them in different sizes. So what if you could have a set of windows with different sizes and you could just pick the window that you want whenever you're building a particular house? Okay, so if you want a window of 3 feet, like 3 feet wide, you have a list of windows, like you have 3 feet wide, 4 feet wide, 6 feet wide. So you could just pick 3 feet wide window and you could use it in the house. And that makes your life much more simpler rather than building things every time from scratch. So that is what web framework is. So let's talk about the popular web frameworks that exist in the market today. Now there are many web frameworks available for different programming languages and each has its own strengths. Okay, we'll talk about some of the most popular ones. So the number one is Spring Boot. Okay, so Spring Boot is a Java based web framework and it is used to build a lot of enterprise applications out there. Okay, and it allows you to build them really quickly. So it takes away the hassles, a lot of auto configuration, and there are a lot of good features that Spring Boot offers to the developers. Okay, but yeah, Spring Boot is one of them and it is Java based. Then you have Django, which is a Python based framework. Now Django is also known as batteries included web framework, which means it includes a lot of common functionalities built in. Okay, so if you learn more about Django or if you read more about Django framework online, you will see this term batteries included being used at a lot of places. Then you have Flask, which is also a Python framework, but it is much more lightweight, flexible, and it is great for small projects or when you need more control over the code. Then you have Express, which is a JavaScript based framework and it's a part of Mean Stack or Mern Stack. Okay, now what I mean by Mern Stack is Mongo, Express, Angular, and Node. Okay, so this is widely used for building APIs using JavaScript. Then you have Ruby on Rails, which is also called as ROR, and it is based on this Ruby programming language. Okay, and it is known for its philosophy of convention over configuration. Okay, and it helps you increase your productivity once you understand its conventions. So that's Ruby on Rails. Now, a lot of these frameworks are being also used by top companies. For example, Instagram and Pinterest use Django internally. Twitter and Airbnb have used Ruby on Rails. LinkedIn uses Express.js for server-side rendering. Netflix uses Spring Boot and so on. So if you learn and Google a bit more about these frameworks, you will know there are a lot of companies, big tech companies, they are using these frameworks for the day-to-day life. Okay, so that's about web frameworks and I shall see you all soon. Thank you. Hey there. So let us begin talking about Spring Framework. All right. Now, let us talk a little bit about history as to how Spring Framework has evolved over years. And if you are a Java developer, it's likely that you would have heard about this particular framework. All right. So this framework was developed by a person named Rod Johnson in the year 2022. Okay. And this was developed as a solution to the limitations of Java Enterprise Edition platform at that time. All right. So the first version was released in the year March 2004. And since then, a lot of developments and versions have been released. So the reason why this was released is to simplify the enterprise application development at that time by providing a lightweight alternative to the complex and heavyweight stack of Java that existed at that time. All right. Now, what does Spring do? So like I said, it was built to provide an alternative to the complex and heavyweight Java Enterprise Edition stack. And since it's an answer to that, Spring simplifies enterprise application development. All right. So once you start using Spring, you will know like how it simplifies a lot of stuff for developers. Right? There are a few key principles that we should be aware of. Number one is simplicity. So Spring will simplify complex technologies, okay, and it's simple to use. Modularity. So it will encourage modular application architecture through loose coupling. Testability. So it will promote good programming practices such as programming with interfaces, dependency injection, and so on. So if you're not aware of all of these concepts, don't worry. Okay, you will understand as you learn more about Spring. But for now, you just need to keep this in mind. All right. Key components of Spring. So there are a few key components that you will hear about often when working or talking about Spring. Number one is the core Spring framework. Now, this is the foundation of the Spring ecosystem. This is core module essentially, I should say, and it provides a lot of features like dependency injection, aspect-oriented programming, transaction management, and so on. All right. Then you have Spring Boot. So this is a project within Spring ecosystem, and this further simplifies the process of building standalone production grade Spring-based applications. All right. And it provides a lot of defaults, a lot of auto configuration, a lot of pre-configured stuff that allows developers to focus only on writing the business logic, application code, rather than wasting time in configuring stuff. All right. You will learn about this, like how Spring Boot makes your life easy when you create your first Spring Boot application. So hang on for that. All right. Spring Data. This is another thing that you will hear about. So Spring Data provides a unified and easy to use APIs for working with various data access technologies. Okay. So whenever you're building an application, let's think of this way. You will be working with data, right? And where does your data exist? Your data normally exists in database, right? And when you work with databases, you have different kinds, like you have relational databases, NoSQL databases. Your database might even exist in cloud or locally, right? So with the help of Spring Data, you can work with different database providers or different data providers with ease. All right. Next component would be Spring Security. So when working with any application, right, security is a must. And this is one of the components that enables you to like secure your application by implementing authentication, authorization, protection against common security threats, and so on. All right. Then you have Spring Cloud. Now this provides tools for developers to quickly build some common patterns in a distributed system. So these are some of the core components of Spring. You can even see that these are the modules within the Spring ecosystem. All right. And there are many more, but these are like the main ones. All right. Use cases. Now, number one use case of making use of Spring is like building enterprise applications, of course, because that is why this was developed, right? To simplify the development of enterprise applications. Okay. Microservices architecture. This is one of the important use cases. So if you are building Java based services that are segregated, all right, and they have been divided into microservices, then for implementing that you can make use of Spring. And it is also used for building a lot of web applications. Okay, so Spring essentially is being used for doing web development. So these are the few use cases of Spring, and this is a short overview of Spring framework. So now it's time that we talk about coupling. And when we talk about coupling, they can be broadly categorized into two types. One is tight coupling and loose coupling. So let us understand what tight and loose means in the context of software design. So coupling in general refers to how closely connected different components of the systems are. All right. Now, understanding these concepts is crucial because they significantly impact the flexibility, the maintainability, and the scalability of software applications. All right. So coupling essentially is something that determines how closely connected different components or systems are. All right. Now your software would have different components, right? Like it might have, let's say, authentication component or some other component. How these components are connected to each other. That is what coupling is, right? And coupling can also refer to the connectivity between systems, right? Now let us talk about tight coupling first. All right. Now what is tight coupling? So tight coupling describes a scenario where software components are highly dependent on each other. All right. Now, this means that a change in one component will necessitate the changes in another, and this would make a system more rigid and harder to maintain. All right. Now, this is what the dependency means over here. Okay, so if you notice, I have used this term highly dependent over here, right? So highly dependent means that if you make a change in one component, that would necessitate that you should make a change in other component as well. That means it's highly dependent on each other. Okay, and that is what tight coupling is. Okay, let us talk about loose coupling. Now, loose coupling, on the other hand, refers to a design where components are less dependent on each other. Okay, now what do you mean by less dependent on each other? It simply means that a change in one component will have minimal or no impact on the other components. Okay, and what this enables you, so this makes your system much more flexible and easier to modify or extend. All right, so if you're making change at one place in your system, it does not mandate the changes to be implemented in other parts of the system. So changes are easier to manage. All right, so that is what loose coupling is. Okay, now an example, if I have to give you, of a loosely coupled system is, let's say you have an application that is interacting with the database. Okay, and there is an interface. Okay, it is interacting with the database through an interface. So if the database changes, you can just adjust the implementation behind the interface. Okay, and this would not affect the rest of the application. Okay, the business logic doesn't need to know the details of how data is stored or retrieved. Okay, so if this is just going over the head, don't worry. When we do things hands-on, you will have a complete clarity about this as to how interfaces make this possible. Okay, but for now, just understand that loose coupling describes a scenario where the software components are less dependent on each other. All right. Also, let's talk about the importance of loosely coupled systems in software design. So number one important thing about them is flexibility and maintainability. So loosely coupled systems are easier to maintain and update. Okay, so if there is any update that is required in one component, it does not require widespread alterations throughout the application, right? So it's relatively really easy to maintain and modify, right? Another important thing about this is scalability. So if your system is loosely coupled, it's easier to scale, enhance features, add new things, because individual components can be improved and replaced without impacting others. All right. Testing. This is another important point when it comes to loosely coupled systems. So if components are loosely coupled, they can be tested independently, right? Because you can really isolate the things and you can diagnose the issues. All right. So these are a few important things that depict the importance of loosely coupled systems in software design. All right. Let us talk about achieving loose coupling. Okay. How can you achieve loose coupling in Java? Number one way to achieve is through using interfaces and abstractions. Okay, so you can make use of interfaces, abstract classes to define contracts between components, hiding the implementation details. All right. So if you're familiar with Java, you will know like interfaces and abstract classes enables you to define contracts. So you can make use of them to achieve loose coupling. So dependency injection. Now this is a technique where components are passed from an external source rather than creating them internally. So for example, if there is a component that has some dependency on another component, so the other component will be passed as a parameter to the first component. Okay, so that it can be used, and this is known as dependency injection. All right. Event driven architecture. So components will communicate through events or messages, and this will reduce direct dependencies on each other's methods or data. Okay, so these are like some of the things using which you can achieve loose coupling in software system. All right, so that's about tight and loose coupling. Hey there. So now it's time that we go a little bit hands-on and understand what is tight coupling and what is loose coupling. So we have understood theoretically as to what tight and loose means. But it's time that I show you, okay, because when you see an example, you get a better sense of what the concept actually means, right? So I am here on IntelliJ. So open IntelliJ idea. Okay, I see a lot of recent projects. Okay, I have been using IntelliJ a lot lately. Okay, so there are quite a few projects that you'll see over here. But what I would do is I would create a new project. Okay, you won't see all these recent projects if you're new to IntelliJ, but I would encourage you all to create a new project here. Okay, make sure you have selected Java here, put in your project name here. Okay, and also select the location where you want your project to exist. Okay, so what I really did is I clicked on this folder icon and I navigated to the directory where I want this project to be created. Okay, once you select the directory, so this is a directory on my desktop under courses, okay, where I wish to have my project being created. And I want to call this project as Spring Example. Okay. And you can see over here, the project will be created in desktop courses, SPFS and / Spring Example. Okay. Select Maven as your build tool over here. Okay. Be sure to select the latest version of JDK. Okay. Anything later than 17 should not matter. All right. And then I would encourage you all to say create, but be sure to select Maven as the build tool because Maven is what we'll be using. All right. And I'm not adding any sample code. Okay. So I'll just say create over here. And what this is going to do is this is going to give me a fresh, brand new project with a pom.xml. Okay. Now pom.xml is a file that can help you manage like all your Maven dependencies. Not your Maven dependencies, but all the dependencies that your project needs using Maven. Okay. I have this what's new in IntelliJ idea, latest version. I'll close this. I'll close this. Okay. Project is up and running. Okay. I have this main folder and what I am going to do is under Java, I am going to create a new package. Okay. So first we are going to see, okay, I'll give you a demonstration of what tight coupling is. So I'll say com.tight coupling. Something like this. Okay, we can create something like this, com.type.coupling. I'll say okay. And we have this package now, and under this package, we'll create some files. Okay, so what we are going to do is we are going to simulate a scenario. Okay, and the scenario is going to be where we want to fetch user details from a database. Okay, and we are going to implement actually a solution, a very simple solution using tight coupling. Okay. So I'm going to create a few classes. One is user database, like so. Okay. This is one class, and then I'm going to have a user manager over here. So I'm going to say user manager, like so. Okay. And then I'm going to have one more class, which is going to be the main class. So I'm going to say tight coupling example, like so. Okay. So I have user database. Okay. Now what this user database is going to do is this is going to access the database and it is going to get the user information from the database. So it is going to have all the code that allows this application to interact with the database. Okay. So I can have all the code interacting with the database, and let us say I have a method over here. Okay. Let's say I want to get the user details, like so. Okay, and I'm going to say return, and I'll say user details from database. Okay, pretty simple. I'm just returning string, and this is just a hypothetical example. Here you can have code, so you can access database over here. Okay, like so. All right, this is done. So I have this user database, and it has a method which is returning me some user information after interacting with the database. All right. Now I have the user manager. So what user manager is going to do is, okay, I have a public method over here. Okay. I have a string. I have get user info method here. Okay. And then I'm going to have curly brace, and here I need to make use of the method that we have created over here. Okay, so this method here. So what user manager is doing is user manager is responsible for managing all the user information. Okay, so it is also going to make use of the methods that we have defined in the user database. So what I need is, I need to make use of this method, and for that I need an instance of user database, right? So here what I'm going to do is, I'm going to say private, and I'm going to say user database. User database is equal to new user database, like so. Okay. Now what I can do is, here I can say user database dot get user details. All right. So we are now able to get the user information from here. Okay. Now let me switch over to tight coupling example over here. So this is going to be the entry point for our application. And here, what I'm going to do is, I'm going to make use of user manager. I'm going to say user manager is equal to new user manager, like so. And here I'm going to, here I'm going to print in user manager dot get user info. All right. Now if you run this, it should run without any issues. All right. You should see the output. You can see user details from the database, and this is the string that you have like hard coded over here. Okay. But if you have any database, and if you're connecting your application to the database, you can have your database logic over here. Now what is happening over here is, user manager is tightly coupled with user database. You can see over here how we are like hard coding this over here, right? So tomorrow, let's say our application evolves and we are making use of database A over here. Okay. So let me add a comment, and I'm making use of database A. Okay. And this A can be anything like MySQL. There are so many database vendors, PostgreSQL. Okay. So let's say you're making use of a database over here, and tomorrow if you want to switch to a database B, what are you going to do? So like B can be a web service. So let's say we are no longer making use of a database. We are now making use of a web service. Okay. Or let's say we are making use of MongoDB now. Okay. We have changed our requirements. Okay. Or something like that. So if there is a change in the database, right? Since this is tightly coupled over here, this coupling is happening over here. Okay. So a lot of code will change, and it will be difficult. Like user manager class will also change. Like you will have to touch the code inside user manager just because the database is changing, which is actually not good. Okay. Because a small change, and these changes frequently happen in your production grade applications. Okay. Now let us see how you would implement the same thing using loose coupling. Okay. So what I'm going to do is, I'm going to like create one more package here. Okay. I'm going to say com.loose, and I'm going to say coupling, something like this. All right. So this is a package, and I'm going to, let's say, copy this thing over here. This entire thing I'm copying over here as well. Okay. And I'm going to close this all. Okay. If you come over here, I have this tight coupling example. I'm going to refactor this, and I'm going to call this as loose coupling. Okay, something like this. All right. And this, okay. So I need to change this as well to loose. It did not ask me automatically. Ideally, IntelliJ asks me whether you want to refactor all the usages, but yeah, that's okay. So now we are here. This is loose coupling example. Okay. Now what you would do is, to promote loose coupling, we are going to make use of an interface. Okay. So what you can do is, you can have an interface or an abstract class as well. We'll make use of interface for the sake of this example, but abstract class can also be used. Okay. So you can make use of an interface or an abstract class that defines the contract for fetching the user details. Okay. So what I would do is, I'll say new interface. Make sure you select an interface here. Okay. And you can say user data provider. So I can call it anything. I'm calling it user data provider. And here I can specify how I want my user details to be fetched. So I can say get user details, for example. Okay. If I want more methods, I can just declare those methods. So get user details, get username, get password, reset user password, and so on. So whatever methods I want to have when interacting with the database, I can define those over here. Okay. Define as in just declare. I won't be providing any implementation. Okay. Now what I can do is, instead of like having the database over here, okay, I'm going to implement. So whatever class I'm going to create, okay, which has the database logic, I'm going to actually implement this provider over here. Okay. Let me show this to you. Okay. So let us say here, instead of user database, I can see this as, let's say I'll refactor this. Okay, I'll refactor user database provider like so. Okay, and I'll refactor this. Okay, and I have this over here. I don't need to get rid of this. Okay, I can simply say implements and I can say user data provider, something like this. Okay, and you can see it is overriding now. This is this thing. This has come over here, which means it is overriding. Okay, you can also add the override annotation over here if you wish to. Okay, something like this. So this is now overriding the definition or like the method that we have in the interface. Okay, and we are providing the implementation over here. Okay, now what we can do is we can go to the loose coupling example over here. Okay, and instead of creating the instance of user manager over here, okay, we have user manager over here, and this is in loose coupling. So what I would do is I would remove this. Okay, I would say user data provider. Okay, so this is our interface. Okay, I'll say database provider over here. Okay, so let us say we are working with the database right now. Okay, and I'll say new database. So here you're making use of class now. Okay, so what you have done is here you're creating an object of the interface. You are instantiating an object and you are assigning the object of the class over here. Okay, you can see this is the class. All right, this is the class. Okay, which means it's an implementation of an interface. All right, and in Java you're allowed to do this. All right, and what you can do over here is now, so this is done. Now what we need to do is we need to make use of user manager. All right, but we have not yet modified user manager. So let's come over here. Okay, so here if you see, we are getting like all the red marks because we have renamed the classes. Okay, which is completely fine. So this was an example of tight coupling where we were like hard coding the creation of the object. Okay, but here what we are going to do now is we are not going to hard code. Okay, so let me show you what we are going to do. So here what I'm going to do is I'm going to have a constructor. All right, so instead I'll have a private user data provider. Now what is user data provider? This is a class member, and if you go over here, this is an interface. So we are like having an object of the or a reference variable of interface over here. Okay, and here I'm going to have a constructor. So I'm going to say generate a constructor. I'm going to say okay, and you can see this is the constructor. Now when instantiating user manager, we are going to provide the implementation as the parameter to this constructor. Okay, so this is an interface, right? Now if you want to fetch the data from the database, you can pass in the object of this class, which is an implementation of user data provider, and it will work over here, right? So these are Java concepts. It will work over here. So let me show this to you. So what I will do is I'll say over here user data provider dot get user details. Okay, so this method remains same, and if you come back to the main class over here, okay, if you are instantiating user manager over here, okay, you can say user manager, and I'll say with db over here is equal to new user manager, and you can see it's asking me for a parameter. So what I can do is, okay, I need to pass in the parameter. So I need to pass in the object of user database provider, right? This class instance. Okay, and here what I'm doing is I'm having the reference variable as the interface, right? So here you can see I'll copy this and I'll pass this here, right? And this should absolutely work fine. Okay, so if I say user manager with db get user info, and if you run this should work absolutely fine. No issues as such. Now you will say, hey, why like so much to do? Okay, the earlier one was pretty simple, right? This is like you're creating a reference variable of an interface over here, and you are like assigning it an object of the class, and then you're passing over here, and here you're handling it, all of that. Why you need to do this? So let me give you an example. Let's say our application evolves. So today we are making use of a database. Let's say this is database A. Let's say our application evolves to B. Okay, Let's say we want to make use of web service and also we want to make use of MongoDB. All right. Let me show you how it will work. Okay. So let's say we want to make use of a web service. No problem. I'm just going to create an implementation of user data provider that talks to the web service and gets the data. Okay. Let me show this to you. So I'm going to say web service data provider. So right now we are having database provider, right? Now I have web service data provider, okay, over here. And what I can do is I can say over here, private, okay. So here in the user database provider, you had implemented this thing, right? User data provider. So here also I'm going to do the same thing, all right? So let me remove this. I'll say implements user data provider. The moment I do this, I get an error. I need to implement this. Fine. And here I need to add a string that fetching data from web service, right? I save this and now see the magic. If I come to loose coupling main class over here, okay, now let me show you what I mean. So here I'm going to create user data provider, okay, and right now I want to fetch data from the web service. So I'm going to say web service provider. Okay, so I'm naming my objects uniquely so that it's easy to distinguish which object you're using. All right, I'm going to create an instance of web service data provider here. I'm going to say user manager. Okay, user manager with web service WS. Okay, and I'm going to say new user manager. And I'm going to pass web service provider over here, something like this. All right. And what I can do is using this, okay, with web service dot get user info, you are now able to fetch data from the web service as well. Okay. You can see over here. It's the same user manager class. We have not changed anything. We have not touched user manager. I'm just closing this. Okay. You just added a new provider. So you have an interface that sets the contracts. Okay, so what it's telling any application developer that joins your team, it is telling him that, hey, if you want to provide data source into your application, you need to adhere to this contract. You need to implement this. So if you implement this, you have to provide implementation of this method, right? The moment you provide implementation of this method, so since this is an interface and class relationship, okay, what you can do is in the main, you can create a reference variable, okay, for the interface, and you can assign it an object of the implementation, which is absolutely valid in Java. And then when passing data, when working with user manager, you are like accepting the implementation of this interface. So whoever implements this interface can make use of user manager. That is how it is, right? Isn't this amazing? And this is an example of loose coupling. Okay, now this is really helpful. And even if you add one more manager over here, so let's say we add one more manager. Let's say I have new database. Okay, so I'll say new database provider, something like this. Okay, new database has come in. Let's say we are making use of Mongo. I'll say implements user database provider. All right, and I will, let's say here, from here, implement this. Okay, and I can say new database in action, something like this. All right, and now I've just added the logic of new database, okay, with the help of user data provider. I've not changed the existing code. A new file has been added. That is it. And what I can do is I can come over here. I can just copy this. Okay, here instead of web service provider, I can say new database provider, something like this you can have. And here you can say with new DB, something like this. Okay, here you need to pass this. Okay, this you need to make use over here. All right, you're done. If you run this, you can see fetching data. Okay, it's giving you fetching data from web service. Let me see why. User data with new DB, user data with new DB, new data provider. Okay, so here instead of web service data provider, it will be new database provider. Okay, so be sure that the instance that you are assigning over here, like the instance, that is what you want to use. Okay, so like you saw, I just used web service provider and the output I was getting was from the web service, right? So it was fetching data using web service. Now I change this, so this will switch to new database. All right, so you can see how adding a new database was easy in our application, and this is a great example of loose coupling. Okay, I hope you have a fair understanding of how loose and tight coupling are working here. So in this particular example, let me close all of this. In this particular example, user manager was tightly coupled with user database. Okay, this example, you can see user manager was actually making use of an interface, right? And whoever implements that interface, okay, it was able to make use of user manager. Okay, so during runtime, whichever object type this reference variable was having, that method was being executed. Okay, that provider was being used. So interfaces are being used over here to promote loose coupling. And I hope you have a fair understanding of how loose coupling is important when you want to design a system that is flexible, maintainable, scalable, and so on. Okay, tight coupling is never scalable. Remember this. All right. I hope this was useful. Welcome back, and it's time that we talk about some of the core concepts of Spring and even understand it. Okay, so there will be few concepts that I'll talk about, and I'll also explain this to you with the help of some source code. So please pay attention. These concepts are really important and will form the base. All right, let's first talk about loose coupling. So loose coupling, what is loose coupling? It's a design principle. It's a way of you designing things that aims to reduce the dependencies between components within the system. Okay, so you can say a system is a loosely coupled system when components interact with each other through an well-defined interface. Okay, and they will have minimal knowledge of each other's internal workings and the implementations. Okay, and they are very modular, flexible, and easier to maintain. All right, let me also explain this with the help of the source code. So this is our project. Okay, we have different data providers. Okay, so this is our user data provider interface, and whoever wants to provide any data into our application needs to implement this interface. So this is like a contract, right? Now we have database provider, we have new database provider, and we even have a web service provider. Okay, you can of course group all these providers into a new folder or a package over here, sub package, and you can organize them. But for now, we have three database providers over here in action. Now, if you take a look at the user manager class, this user manager class is dealing with the interface here. So this is the interface, right? This is not the class. Okay, so if you are making use of any of the classes over here, which means any of the interfaces over here, sorry, not interfaces, which means any of the implementations over here of user data provider. Okay, this would make user manager tightly coupled. So if you are making use of, let's say, web data provider over here, okay, web service data provider, this is an implementation of user data provider, right? And since this is an implementation, this step or this move is making user manager tightly coupled with web service data provider. But we are not doing this. What we are doing is we are making use of an interface over here to interact with the web service data provider if we want to, right? And this kind of a setup means that the underlying data provider can change without modifying the user manager's code. How? We have already seen this, right? So if you try to add a new data provider, what would happen is there is no change in user manager. Okay, you have to just add the new provider, and then you have to go into the main class over here. So we had this main class created, and you need to just call it. That is it. You're not making any changes, anything into user manager. And why is this? Because we are interacting with the providers with the help of an interface, and we are not directly making use of the implementations or the providers directly. We have an interface in between. Okay, and this is very helpful in promoting loose coupling, and this is what loose coupling is. All right, so I hope this is making sense. So this is loose coupling. Let's go ahead and let's talk about inversion of control now. So inversion of control is also a design principle. It's a concept that exists where the control of the object creation and the lifecycle management and everything about an object is transferred from the application code to an external container or a framework. All right. Let me explain this. So in simpler terms, inversion of control or IOC, this is also called as IOC. So it means that instead of your code managing, creating the objects directly using the new keyword, the control is inverted, okay, and objects are provided to you by the framework or container that you're using. Let me explain this to you, okay. So I'll switch over to ID here. Here in the ID, what is happening? So if you need an object of this, so this user manager needs an object during runtime of user data provider. So the type should be of user data provider, right? Now what is happening is here during runtime, you are calling user manager over here with different object types. So you are calling first with user database provider, then you're calling with web service data provider, then you're calling with new database provider. So different object types, you're making use of different object types to call user manager, right? So what is happening is here during runtime, right? During runtime, this particular class over here, this main class, okay, loose coupling example, this is having the main method. So this particular class is managing the object creation and it is making sure that user manager gets the appropriate object during runtime, right? So this is being managed in the code right now. So this is not inversion of control, right? What is inversion of control is if you don't manage this in the code and if this management of providing the object during runtime is handled by the framework itself. And which framework am I talking about? It's the Spring framework, of course, because that is what we are learning, right? So if Spring framework somehow provides us the object during runtime, so we won't be dealing with this step over here. We won't be dealing with this step, okay? So if I comment this step and Spring framework somehow provides me the object during runtime, that is what is known as the inversion of control, okay? And why it's called inversion of control? Because right now we are controlling it, right? We are controlling it with the help of this code. And this control is passed on to Spring framework, which means that the control is inverted, right? So you are passing on the control of doing this to Spring framework, right? So this is inversion of control. You are like inverting, or there is an inversion over there, right? So this is what the inversion of control concept, okay? And this is one of the important concepts when you're talking about Spring framework. So when you are reading about Spring framework anywhere on the internet or any books or anywhere, you will come across this particular concept. It's really important that you understand this in a simple way, okay? So here I have this example put up purposely, okay? So we purposely manage the objects first, right? So instead of user manager creating the class over here, creating the object over here, okay, what we are doing is we are making use of this particular class and we are injecting this particular object into user manager, okay? And who is doing the job of injecting this? We are doing the job of injecting. This loose coupling example class is doing the job of injecting it into the user manager, right? So this is inversion of control at work, but this is not actually being managed by Spring framework right now. So when it's being managed by the framework, it is known as Spring framework. But right now we are only controlling it, right? I hope this is making sense. So we will be soon switching over to inversion of control where we will allow Spring framework to manage it, okay? But right now I'm managing it so that you get a better sense of how this is being managed and how bringing Spring into picture will make your life easy. That also you will understand, okay? So to understand how Spring is making your life easy, you should also understand the toughest part first, right? So if you do things the hard way and then if you switch to Spring, my belief is that you will understand the value of Spring framework even better, okay? Because you went the hard way first and then you are adding Spring framework and then you're understanding, oh wow, Spring does all this automatically, okay? So that's the aha moment that you will go through, all right? But that is what inversion of control is, to put out in a very simple way. Inversion of control. So the control right now that is happening of the object management, object creation, and the dependency injection. Okay, so we are injecting the dependency, right? User manager is dependent, like user manager needs this particular thing here, right? And it is dependent on this, right? We need to provide this dependency. So this process of providing the dependency is known as dependency injection, right? So who is providing this? We are providing it from here. Okay, so we are controlling it, and we'll soon pass over this to Spring Framework, and that is when inversion of control will be in action. Okay, so this is inversion of control, dependency injection. Now, what is dependency injection? I just spoke about it. Okay, so dependency injection is also a pattern that is commonly used in object-oriented programming languages like Java. Now, what happens over here is the dependencies of the class are provided externally rather than they are being created within the class itself. So what I mean over here is, okay, if you take a look at this code, here we need this dependency, right? We need an instance of this type, right? Are we creating the instance of this type within user manager itself? No, right? We are bringing it externally with the help of this constructor. So whoever is creating the object of user manager has to provide this. Why? Because this is a dependency. So I'm telling whoever is calling user manager, I'm telling them, hey boss, I need this whenever you are creating the object. So if I try to create an object without this, okay, you'll get an error, of course. So I'm telling the caller that, hey, you need to provide a dependency which is of what type? Which is of user data provider. So see over here, you're getting this in the syntax as well, right? So you have to pass this. And what you're doing over here is you are injecting the dependency, right? This is being injected into user manager, right? And what is injecting? Injecting means you're providing something externally, and that something is typically the dependency itself, right? So this is what dependency injection is, and we are using this concept in our source code, all right? So I hope this is clear now. And coming over to the concept of beans. So if you've read about Spring Framework, or if you're a Java developer, you must have heard of this concept of beans. Okay, what is beans? Objects that are managed by frameworks are known as beans. This is the simplest definition of beans. Now let me explain this better. Okay, so let me come over here. Here I just said, okay, here we are providing the objects during runtime, right? We are providing the dependency to user manager during runtime, right? You would agree to this? Object is being created, we are providing it during runtime. Object is being created, we are providing during runtime. Okay. We are making use of new keyword as of now. You can see new keyword is being used at so many places, right? Now, if we are making use of Spring features, okay, we won't be creating the dependency, but instead Spring would be doing this for us. It would be managing the life cycle. It would be injecting the dependency on the fly, right? Now for Spring to do that, it has to manage the objects, right? It needs to become a manager. It needs to manage the object so that it can provide whoever needs it during runtime, right? So in order for Spring Framework to allow the management of objects, this concept of bean exists. So bean is nothing but an object that is being managed by the framework. Now, which framework I'm talking about? Spring Framework, of course. So if we want like user data provider to be managed by Spring, we will make it as a bean, and that is what a bean is, right? So this is the simplest explanation of bean and what it is. All right. Now, when I say that the framework is managing beans, okay, or managing the objects, it means that it is managing everything about the object, like the life cycle, the instantiation, and everything, right? And we need to provide something called as configuration to Spring Framework, which talks about the details of the objects that Spring Framework needs to manage. All right. And this configuration is normally provided using a configuration file. So you just need to have a configuration file, and you need to have that in the project. Spring will pick it up, and it knows, okay, these are the objects that I need to manage, and these are all the beans. All right. And Spring Framework will take care of the rest. All right. So that's about these concepts, people. So these concepts are really important, like the concept of loose coupling, really important. Inversion of control, it's really important. We don't have this implemented yet in our project, we are controlling the object management and the injection of the dependencies that is also being managed by us right now. So in order to get Spring to do that, we need to use the inversion of control, right? Dependency injection, we saw what is dependency injection, and beans. So these are the 4 important concepts that you need to understand when learning Spring. I hope this was super useful. So let us now talk about Spring Container and configuration. Okay. So what is a Spring Container? So Spring Container, you can think of it like a box. Okay. And it manages the creation, management of the objects in your Spring application. So if you have the application running, like a Spring application running, okay, you might want Spring to manage your objects, right? And Spring, with the help of Spring Container, manages the objects. So you can see this box is a Spring Container, and then you have these objects 1, 2, 3, 4, and the entire life cycle of the objects is being managed by Spring Container. So it takes care of the life cycle management. It provides the objects on runtime. So if any of the classes or any of your code needs these objects during runtime and is dependent on this, so this dependency injection is being done by the Spring Container. Okay, so all of this is being taken by Spring Container, and it is one of the important concepts in Spring framework. Okay, so this is Spring Container. Okay, now there are 2 types of Spring containers. One is the application context. Okay, and there is one more called as Bean Factory. Okay, Bean Factory is the simplest container which provides basic support for dependency injection. Okay, and application context is a little bit more advanced container than Bean Factory. Okay, and normally people use application context only, but these are the 2 types that you should be aware of. Now we have a Spring Container. Okay, it is managing all the objects. Okay, but one question I would want to ask: how does Spring Container know which objects to manage and where are they defined? So all of that, the details of what to manage, who will tell Spring Container? So we as a developer are responsible to tell Spring Container that we want to manage these objects, and we can tell Spring Containers with the help of a configuration file. Okay, so we'll have some configuration defined created in our project that will be picked up by Spring Framework. And with the help of that configuration, the Spring Container would know, okay, these are the objects that I need to manage, and it will pick up those objects and it will instantiate them. Okay, and it will do everything that it needs to. So this is something that you need to know. So configuration files is something that you need to define to tell which objects are supposed to be managed. All right. Now, what does configuration files contain? Configuration files will contain the Bean definition. Okay, so if you want an object to be managed by Spring Framework, you need to make or declare that particular object as a bean, right? Only then it will be managed. And the configuration file will have the Bean definitions. Okay, and definitions meaning like a few lines of code which tells, okay, this is the class and this is something that needs to be managed by Spring. And there is a syntax for that. And Spring Framework will do the rest. Okay, you don't need to worry about the rest. All right, so that's about the Spring Container and the configuration files. So let us now start setting up a Spring project. All right, so I have this project already open, Spring example. Okay, and if you take a look at the project structure, we created this as a Maven project, right? And whenever you create a Maven based project, you get this special file called pom.xml. And this is a file that has the list of all the dependencies, the project configuration that you need. Okay, so you can see over here that we have like some versions defined here. You can see we have the JDK version. Okay, so this is Java 21 version, compiler target. That is something that has been defined. And this is something that we selected during the project creation. Okay, now what we need to do is we need to convert this project into a Spring project. And how are we going to do that? So we are going to do that with the help of Maven by adding some dependencies over here. Okay, so we need to tell Maven that we need to add some dependencies. So understand this, people. We are making use of Maven. Now earlier, even before Maven was there, if you want to add some dependencies into the project, you had to go to the Google. You had to get the jar files, .jar files of that particular dependency. And you had to add that dependency into the project. Okay, like you had to add those jar files. Okay, so when I say you had to add dependencies, it means you had to add those jar files. But now with Maven, what happens is you just specify the dependency over here in this file, and Maven will do that job of getting the jar file for you. Okay, because I've worked in early days of Java, I used to code, and I have added the jar files into the project. Okay, and trust me guys, it was very difficult because there would be instances wherein you would download a wrong jar file. Okay, and it was very manual. You download, then you copy it to the project location, then you go to the project properties and you add that jar file. But here Maven is making your life easier. Okay, so what we need to do is we need to add two dependencies. Okay, so I'll come over here. I'm going to search for Maven repository over here. Okay, so what is Maven repository? Maven repository is a repository of all the Maven dependencies that you can search, browse, and explore. So this is the official website. You can click on this, all right? And over here, you can search for literally all the dependencies. So since we need Spring dependencies, so we are going to add two dependencies to convert our project into a Spring project. First one is Spring Core. Okay. Now what is Spring Core? So if you see over here, basic building block for Spring that in conjunction with Spring Beans provide dependency injection and IOC related features. And you can see this is the official one. So I'll just go over here to Spring Core. And on this particular page, you are going to see over here, you can see like all the details of this dependency. And here you can see the versions. You can see so many versions over here. Okay. So depending on when you're watching this video, there is a possibility like new version might have come in. Okay, so you can see there are versions being released very frequently, you can see. Okay, so you might see some new version come up over here. Don't worry, just select the latest one and just add it based on the steps that I'm showing you. Okay, because these version updates are really frequent, and I'll update the video if anything significant is introduced or anything changes. All right, anything significant changes. So just click on this. You can see over here, this is the dependency and this is something that you need to add. And you can see over here, Maven, this is the Gradle, this is Gradle Short, Gradle Kotlin. So you have different options over here, depending on which build tool you are using. We are using Maven, right? So I'll copy this, I'll come over here and I need to add this over here. Now to add this, we cannot directly paste it. So of course we'll have to paste it, but before that we need to add a dependencies tag like this. Okay, because under this tag we are going to have all the dependencies added. So I'll add this tag and within this I'll add this dependency. Okay, so you'll see a few red marks, which is absolutely fine. Don't worry about those red marks. Okay, but we added Spring Core. Now what is Spring Core? Spring Core is the foundation of Spring Framework. Okay, it has all the building blocks that our application would need, like all the core utilities and all. Okay, so if you are wanting to convert a Maven project into a Spring project or any project, even if you're using Gradle, you need to add Spring Core. Okay, the next dependency that we are going to add is Spring Context. Okay, that is also important. So I'm going to go over here. I'm going to search for Spring Context. This is the one. So you'll go over here, select the latest version like you did for core, copy this, come over here, okay, and you can paste it. All right, and you can save this. Okay, so this is done. Now what you need to do is, okay, whenever you change anything in the pom.xml, what you need to do is you need to reload the changes. Okay, why you need to reload? Because depending on whatever changes you have done, okay, what Maven is going to do is it is going to fetch all the dependencies and it is going to store all the dependencies over here. in the external libraries. Okay, so you can see right now we just have Java 21 as the dependency here, right? There's nothing else. Now let me do a refresh. So you can hit refresh over here from here, or you can go to Maven on this M icon and you can also hit refresh over here. Okay, so that is also going to do the same thing. Okay, just in case if you don't see the refresh over here, right? Now you could see when you hit refresh, you'll see some processing at the bottom where it is going to fetch everything. And the moment processing is done, you're going to see the external libraries folder just got updated. You can see, okay. You can see you have, so we had added Spring Core and Spring Context, but you can see a lot of other things have also been added. And these are all related dependencies that our project would need, okay. So we literally didn't have to do anything. We just specified the dependency over here, and Spring, or I should say Maven, did a wonderful job of getting all the dependencies, all the jar files. You can see these are all jar files from the internet. You can see, okay. So this is for your information. Okay, you can keep a check on the external libraries folder over here. Okay, so this is about configuring a Spring project. We have just added dependencies, and with the help of these dependencies, our project is now ready to make use of Spring features. All right, so I hope this was useful, and I hope you are able to follow the steps. Welcome back. So we have our project set up to work with Spring, or to make use of Spring framework. You can see the dependencies have been added in pom.xml. Now what we are going to do is we are going to get started with creating our first bean, and we are going to create a very simple bean. So it is going to be a very simple class which does something really simple, and we are going to get Spring to manage the objects of that class. All right, so first, what we need to do is we need to make sure that the dependencies of Spring are added, and we are working with a Spring project. And that is something we have made sure. Now what I'll do is, as a next step, I need to have a class whose object is going to be managed by Spring. So I'm going to say new Java class, and I'm going to create this particular class in car.example.bean package. All right, this is a sample package that I'm creating, and I'm going to name this particular class as my bean, something like this. You can call it anything you want. Okay, so this is done. My bean is created. All right, and you can see the package is also created because I entered the fully qualified class name. All right, now what I'm going to do over here is I'm going to have a property or a class member. I can say message. Okay, so this is a bean which has message in it. All right, and what I need is I'll generate some code over here. I need a setter, so we are going to set the message. Okay, and I'm going to print the message. So I'm going to say public and void show message. Okay, something like this, and then I'm just going to say message, and here I'm going to say message. All right, this is done. And also I can have a string representation over here, so I can override this string like this. All right, so this is our class, very simple class. It has one class member message. We also have setter inside, show message, and toString. All right, so this is done and ready. Now what we need to do is we need to get Spring Container to manage this particular class object for us. All right, and for that we need to have a sort of instruction which we are going to provide with the help of configuration file, and we are going to make use of XML format for the same. All right, so what I'm going to do is I am going to head over to resources here. I'm going to right click and I'm going to create a new file here, and I'm going to call this particular file as application bean context.xml. All right, now we need to add some code over here. Okay, and to add that I'm going to switch over to our browser because there is going to be a little bit of boilerplate code that we need to add. So I'm going to say over here XML schema based configuration for Spring. You can search for this XML schema based configuration and you're going to get this official URL which is 40 XML schema based configuration. And this is from the official link. So just click on this. I'll just zoom in a bit, scroll down, and here you are going to see this equivalent file in the XML schema style would be. Okay, and you need to just take this over here. Okay, and you need to come over here, paste it over here. Okay, and you can see this is how the XML starts. All right, we need to add something like this to get started with. All right, so this is done. Okay, we have the bean tag open with some code over here. Okay, now what this code does is this code will set up the necessary XML namespace and schema details to allow you to correctly define and validate Spring Beans. All right, so here you can see the bean tag. Okay, we are setting the XML version first of all and the encoding at the top. Then we are setting up the schema location, you can see, and the namespace. All right, so this is the starting part. Now what we need to do is you need to define the bean. So if you scroll down a little bit, you can see like this particular tag over here. Okay, bean ID, you can see here this as well. All right, so this is bean and you have to specify the ID. ID is nothing but like the name of the bean with which you want it to be identified, and class is nothing but the location of the bean. So what I'm going to do is I'm going to copy this again. You can even type this out. Okay, it's not much. I'm going to copy only the bean tag here, not the property. Okay, property is something that will come to a little later. But here I'll type in bean and I'll close this bean tag, something like this. All right. So now over here, we are providing the definition of the bean. So under beans tag, we have a bean definition. ID is nothing but the identifier of the bean. And I'm going to just call it my bean. Class. So what is the class? Class is going to be a fully qualified class name. So I'm going to say car.example.bean.mybean. Okay, you can see IntelliJ was really helpful here. Okay, so this is done. Now this is the XML configuration. We have given the bean definition. So we are telling Spring that, hey, I have this class created here. Okay, this particular class at this location. I want this particular class to be managed by Spring Container or by Spring Framework. And this is what the identifier of this class is. So if I say I want the object of this class, you need to provide it. Okay. And I won't be making use of fully qualified class name, but I'll be making use of this ID over here. All right. That is done. So now what you need to do is we need to head over here. Okay. And here under this package, I need to add one more class, and I'm going to call this particular class as app. You can call it anything you want. Okay. And this is a class that is going to have the main method, something like this. Okay. Now what we are going to do is we are going to make use of the class that we have created. Now we'll be writing some code to make use of the bean. So first I'm going to load the Spring context from the XML configuration file. So I'm going to say application context. I'm going to say context is equal to new class path XML application context. And over here, I'm going to have the name of the XML file. Okay, so I'm going to say application bean context.xml, something like this. Okay, just make sure you don't make any spelling mistakes here. Otherwise, your code won't work. Okay, so, okay, this line is a little bit long, so I'm going to just take this to a new line. Okay, so I have this Spring context being loaded. Okay, now what I'm going to do is I'm going to say my bean is equal to context dot, you can see this get bean method, and here I'm going to pass which bean I want. So what is the identifier of the bean? It is my bean. Okay, and then I'm going to simply say system.out.println my bean. I'm getting this red line over here, so I'm going to just cast this to my bean. Let me run this. You can see the output over here. So this is coming in from here. Okay, this toString method in action. Okay, so it is giving us a string representation of this particular class object. Okay, so we are able to get the object, but right now the message is null. Why is it null? Because it was not initialized. There is no initial value. We are not calling the setter or anything. Okay, so just head over to app.java and let us understand what happened over here. So it was a 3-step process. Okay. In the first step, we first loaded the Spring context from the XML configuration file. Okay. So what we did is we made use of application context. And if you go inside, this is an interface. You can see this is an interface in Spring representing the IOC container that manages the beans and the dependencies. All right. And we made use of class path application XML application context. So this is a specific implementation of application context. And this implementation loads the context definition from an XML file located in the class path. Okay. And this class is responsible for setting up and configuring the Spring container. Okay. And as the argument, as you can see, I have passed in the name of the XML file. And this is the XML file that contains the Spring Bean definition as to where is it located, its ID, identifier, and so on. Okay. So it's loaded, and Spring container, with the help of this XML file, knows that this is the class that I need to provide when requested. Now in the next step, what we did is we retrieved my bean from the context. Okay. So what we are doing is we are making use of getBean method. And we are saying that, hey, from the context, give me my bean object. I need that. Okay. And since this is being managed by Spring now, Spring gives you the object of the same. Okay. And then we are just displaying the bean information. Now, one small problem we have over here, in fact, I would say 1 second. So if you run this, you saw that we were getting the message as null. Okay. And here, if you go, you saw something called as property. Now, what is property? Okay. So property is a tag which is used within the bean definition within your XML configuration file. And what it does is it provides the values for the attributes defined within the class. Okay. So over here, if I want to initialize message with some value, I can provide that with the help of property. Okay. So what I can do over here is I can come over here. I can say property, something like this. You can see property name. I can say message. So what is the name of the property? It's message. What is the value I need to provide? I am a first bean. So I can provide any value here. Okay. This is done. I can close it this way. Let me run this again. Okay. Let us run and see. You can see the value is now being populated over here in the message, and it is being printed with the help of toString. Okay. Now what happened over here? Okay. So what happened is when you added property, what Spring context IOC, Spring IOC does is it invokes a setter, like the corresponding setter from the class. Okay. And it will set the value over here. Okay. So whatever value you're passing, so it will look for message over here because property name is message. So it will look for message, it will look for the corresponding setter, and it will set the value. Okay, that is what Spring IOC container is going to do. And this call to the setter is being done automatically. We are not doing this. We have just told the Spring IOC container via this configuration file that, hey, this is a property that you need to initialize, and this is the value. Okay. Okay. It will also work without this property tag. We did an execution without this property tag, but the value that we got was the default value, right? And default value can be anything. It can lead to errors, but if you want the attributes to be initialized properly, you need to make use of property. And if you don't have a corresponding setter, so let me comment this. If you don't have a setter and if you're making use of property, let me run this. You can see you get an error. If you scroll up, you'll see it clearly says error occurred, exception occurred during context initialization. Okay. And what is the error? Creating bean with my bean defined in class path resource has failed because invalid property message of bean class. Bean property message is not writable or has an invalid setter method. It does not have a setter. We commented the setter, right? So that's the problem, and it is not able to create that bean, and the application has ended, right? So I'll just uncomment this. I'll run this, and you see this absolutely fine, right? So yeah, this is the entire mechanism, and here you can see like the dependency injection also in the work. Okay, so you need this object. Okay, this is provided to you by Spring. Okay, and you can see like how Spring is managing, and whenever you ask for it, it is simply going to provide that particular thing to you at any point in the program. All right, so that's about bean creation and how you can create your first bean. I hope this was useful. So now it's time that we talk about the life cycle of a bean. What is a bean? Objects that are managed by frameworks are simply known as beans. And to work with beans, you need to have something called as bean definition, which will include the configuration metadata that the container needs to know to create and manage the bean. The bean configuration or the bean definitions can be provided in various ways, like XML configuration file. You can even have annotations and Java-based configuration. Beans are configured using XML files where each bean is defined within bean tag with attributes specifying class, properties, and even dependencies. You can even make use of annotations like component, service, repository, and these would be picked up by Spring and managed as beans. Now let us talk about life cycle. So the first step in the life cycle of the bean is instantiation. So this is the first phase where the bean instance is created using the bean definition and the constructor injection. Then the population of properties would happen, which means that the properties would be set on the bean instance either through the setter, constructor, or field injection. Then you would have initialization. So during this step, the initialization method is invoked after the properties are set. Then your bean is marked ready for use, and once the bean is used, it is destructed, okay, or it is removed from the container during the application shutdown. So this is the typical life cycle of the bean. Okay, so that's about bean life cycle, and I hope this was useful. It's time that we talk about dependency injection. So dependency injection is a design pattern that is used in software development to achieve loose coupling. Okay, and we can achieve loose coupling by removing the direct dependency instantiation. So whenever there is a dependency, normally you instantiate one class within another, right? And with the help of dependency injection, you can simply remove that instantiation process, and the dependency can be provided on the fly during runtime. How it can be provided? It can be provided with the help of dependency injection, and there are two ways of doing so, or two types I can say. One is constructor injection and other one is setter injection. So these are the two types of dependency injection that exist. And now let's head over to see how constructor injection and setter injection work. So now it's time that we talk about constructor injection. What is constructor injection? Constructor injection is a type of dependency injection where dependencies are provided to the class that is dependent through its constructor. Simple. Okay, so here to provide the dependencies, constructor is being used, and that is why it is called constructor injection. And how is the dependency provided? So of course, we are making use of arguments and parameters to the constructor when the dependent class is instantiated. All right. And this particular thing, constructor injection, ensures that the dependencies are available when the object is created. Let us take a look at a hands-on example for the same. And I'm going to switch over to IntelliJ. So now over here in IntelliJ, what I'm simply going to do is I will create a new class. Okay, so we are going to take a new class example. And I'm going to have this class as, let's say, specification. Okay, so this is a specification class for the class car. Okay, so we will be having two classes. One is the car class and another one is the specification class, which is going to maintain the specification of the class. Sorry, not of the class, but of the car. Okay, and this way we are creating dependencies between two classes, and we'll take a look at this example. Okay. So specification, and I'm going to say car.example.constructor. dot injection, something like this. Okay, you can call your package whatever you want, but I'm making use of this here. Okay, and I'll also need one more class over here, which is the car class. Okay, this is done. I'll also need one more class over here, which is the app. Now this is going to be the main class. Okay, I'll close this and we'll come over here in the coding editor. Now in the specification, let me store a few specification, like a few properties about car. So what I can say is I can say private string, and I can say make. So this will store the make of the car. Then I can say private string, and I can say model. Okay, this will store the model of the car. Okay, what I need to do is I'll generate getter setter like so. Okay, I will also get the toString created. Okay, like this. Okay, so this is also done. Okay, we have our specification class set. Now within car, what we are going to do is we have this car class dependent on specification. So we are going to simulate that scenario. We'll say specification. Okay, and now what we need to do is we will be having a, let's say, generate over here. And I can say, okay, I don't need to use generate. In fact, I can say public void display details. So we are displaying the details of the car. And how are we displaying the details? We are saying system.out.println. I'll print in car details like this. And I can say specification dot toString. Okay, I'm just getting string version of specification object here. Okay, now what we need to do is we need to have a configuration created as well. So now to define the configuration, I'm going to open the project structure. I'm going to head over to resources and I'm going to create a new file. And this file is going to be a new application, a new XML file. Sorry. So I can call this as application. And since we are talking about constructor injection, I'll just make it explicit. Constructor injection.xml. Okay, we'll need some boilerplate code, so I'm just going to copy it from this particular file and I'm just going to move it over here. Okay, we're going to change a lot of stuff over here. All right, so this is like the bean tag. We leave it as it is. Okay, here in the bean tag, we first create the bean of car specification. So I'll say specification, something like this. And then here I can say car dot, I can say constructor dot injection dot, and okay, let me see what is the path. Car dot example dot constructor dot injection. Okay, so let me copy this so that I don't make any mistake here. Okay, so I'll come over here and let me paste this over here. Dot, and you can see the specification up here. Be sure to have the right fully qualified class name over here. Okay, that is important. Now what I'm going to do is I'm going to set some properties. I can say make. What is a make? Let us say Toyota. Okay, you can have any favorite car make over here. Okay, doesn't matter. We are learning. Model is, let's say, Corolla. Okay, this is done. This bean is set. The ID is the car specification. So what we have done is we have defined the dependent bean over here. This is the dependent bean. Okay, so this bean is needed by car class, I should say. Okay, so car needs this as a dependency. So we first defined the dependency. Now we'll come over here. What I need to do is I will have bean over here, and then I'm going to have like the ID here. Okay, what is the ID? I can say my car. You can give this any sensible identifier over here. You can add class over here, and you can say car dot example dot, you can say constructor dot injection dot car. Okay, and then come over here, and now here things become important. Okay, so we have this bean. Okay, and this bean that we are newly creating now needs this as the dependency, right? So car needs specification as the dependency, right? Specification as the dependency. So what we need to do is over here, we need to add a tag, okay, for doing constructor injection. So you can see the list of tag over here, okay. So here you will see one tag which is constructor arg, which is constructor argument, okay. Now this tag is used to define the arguments that are passed to the constructor when a bean is created, okay. And what we can do is we can have this created over here like this, okay, and you can say reference. What is the reference? Car specification. Just be sure that the ID matches exactly the ID that you have defined over here. Otherwise, like, it won't make sense, right? Now we are saying like pass this as the constructor argument, but we don't have the constructor defined over here, right? So what we can do is we can have a constructor. Sorry, I just pressed the wrong button. You can say constructor like so, okay. Constructor is done, okay. I think we have done the dependency as well, like the configuration over here as well. Now we need to head over to app.java, okay. And what we need to do over here is we need to add public static void main. I need to say the application context as context, new class path application context, and I'll move this to the new line, okay. And over here I need to pass in the name like application. Okay, 1 second. So what is the name? Application. 1 second. So I'll just copy this name. That will be better. Also, I just feel 1 second. I just feel like instead of construction, it should be constructor. Okay, like this. And I'll say refactor. Come over here and add that over here. Okay, and you need to add the .xml. This is done, okay. So yeah, I'm loading the XML, okay. Now what I need to do is I can say car, okay. I can say my car. Let's say my car is equal to context.getBean. I can say my car over here, okay. This is the ID, okay. And what I need to do is I can cast this, okay. So there was one more option as well, if you see. Okay, let me like hover on this. Okay, so one more option, you can even change the my car type to object. So I don't want to do that. Okay, I need to retain the object type. Okay, so I can have now my car dot display details, something like this. Okay, let us see what is the output that we get with this. So I'll run this. Let us see. So you can see specification, which is make is Toyota and model is Corolla. How are we getting this? Okay, we are getting this with the help of this process called constructor injection, which we are doing over here. Okay, so we are creating a bean and then we are injecting it via the constructor. Okay, and how are we doing this? With the help of this particular tag in the XML. So what is happening is during instantiation, the Spring container is looking for this constructor here, and it is making sure that it is passing in the bean over here, which is of type specification. All right. So that's about constructor injection and how you can make it happen in your projects. So now it's time that we talk about the setter injection. So in constructor injection, we injected the dependency with the help of this constructor, and we made use of a configuration file over here. Okay. So what I'm going to do is I am going to create a new class. Okay, I'm not going to make use of same package, but I'll create a new class called car. Okay, and it will exist in car.example.setter.injection, something like this. Okay, this is created, and in fact a lot of code will be similar. So let me just copy the constructor injection files into like the setter injection. Okay, something like this. And now if I see over here, okay, here you see app, car, and specification. Okay, so you have a specification, you have car. Now this car is being provided the dependency with the help of a constructor. what I'm going to do is I'll remove this and I'll add a setter. Why a setter? Because of course we are talking about setter injection. So we need a setter. We'll get rid of constructor. Okay. Rest everything remains same. I will duplicate this XML as well. And here I'll say application.setter injection. Okay. Something like this. Okay. Now over here, what I can do is here, if you take a look at the configuration, we are making use of constructor arg tag over here to inject a dependency using the constructor. What we can do is I'll get rid of this. And since we are making use of setter injection, okay, we can make use of property. So with the help of this property tag, you are instructing to make use of setter injection. Okay. And we are already using setter injection over here. Okay. So here these values are being initialized with the help of the setters that you have defined over here. So these setters that you have defined, this set make and set model is being called because you have added these two property tags. So same goes for car class. You'll say name, okay, here. And what is the name of the property? So name of the property is specification. So you will add this over here. What is the reference? Okay. So, or what is the value, not reference over here. Okay. So value, we need to add this bean ID. Okay. Like so. And you need to add the closing tag. Done. Okay. Now let us come to app.java. Here, instead of loading this application constructor injection, I'm going to say setter injection.xml. Okay. Let me run and see this. Okay. Let us see what happens. So here we are getting an error. It says that it's not able to create this bean because there is no default constructor found in car. You can see this is a class. So, okay. And it is pointing us to constructor injection car. So there is a problem. Let me see what the problem is. Okay. So the problem is here when, so since we copied the files, we updated the property over here, but we did not change this fully qualified class name. So it should point to setter injection.car, right? Now it should be okay. And let us run and see what is the error that we get. Okay. If you scroll up over here. So the error says it is not able to create a bean defined over here in this XML. Okay. So there seems to be some issue in the XML. Let us check our configuration. All right. So we changed setter over here, but we failed to change the setter over here. We are still referring to constructor over here. So if you're copying XML files, just be careful. Okay. That you're changing everything and you're pointing to the right files. All right. And one more thing I believe we need to change here. We are having a value as that of property, but here we need to have that as reference since we are referring this to another bean over here. Okay. So this will be ref. And now let me run this. Let us see. Okay. So it works perfectly fine now. You can see. And what is happening over here is we are making use of setter injection. So this is the setter. There is no constructor as you can see. And we made use of property tag for the same. All right. So I hope this was useful and I hope you have clarity about setter injection in Spring. So welcome back, and now it's challenge time. So we have come very far in understanding the Spring concepts and how things work. One of the examples that we took a look at was this loose coupling example where we worked with database providers, like data providers. So one was the new database provider, then we had user database provider, and then we had a web service data provider. So these were the three implementations of user data provider, right? So this interface user data provider had three implementations, which were these. And then we made use of user manager, which had a dependency on user data provider. And we were manually passing this dependency using this constructor. Okay, so if you go to the loose coupling example over here, we were passing this dependency manually. So you can see this dependency, we were creating the instance of this, and then we were passing it over here. Okay, user data provider, you can see. Okay, web service data provider. So if you want the data from web service, we were instantiating manually and we were passing in the dependency. So what we need to do now is, the challenge right now is you understand what is IOC. you understand what is like dependency injection, constructor injection, setter injection. So we need to implement IOC over here, inversion of control. Right now, we are managing the objects. Okay. Now we want to get Spring to manage the object. And of course, this is a Spring project. So if you have been following along, we have added the Spring dependencies as well. So we have Spring over here. And this example we wrote was before configuring Spring into our project. So we need to make use of Spring features now and get rid of managing the dependencies ourselves. Okay, because we have such an amazing tool at work. So why would we do the work, right? We should get the tool to do the work. So what I would recommend you all is to start implementing this. Okay, I'll give you a few hints over here. So we have this user data provider, which is being passed to user manager as a constructor. The implementation is being passed over here, right? So what you need to do is you need to make use of something called as constructor injection. Okay, because we're making use of constructor over here. So this code won't change absolutely. You'll be just adding the XML file to inject the bean. Okay, first you will get the bean created for all the implementations. Okay, and then what you can do is you can pass in the dependencies. All right, and with the help of that, okay, what will happen is you will be able to inject the dependency into user manager. Okay, and then in this main file over here, you need to create the context, load the configuration, and directly request the IOC container for the beans that we have created. Okay, and we won't be instantiating the bean, but Spring IOC will help us with that. So just try to attempt this. Okay, pause the video right now, try attempting this, and then play the video again to watch the solution. I would be having the solution right now. Okay, but I want you to try out first. Remember, the goal is not to get the right answer here, but the goal is to go hands-on and to test ourselves. Okay, the more hands-on you go, it's okay if your answer is not correct or if you're not able to solve it, that's perfectly fine. It's understood. But the point is you going hands-on will help you understand things, and that's really important. That's the goal of this exercise. Okay, not getting the right answer. Okay, so pause the video and try attempting this. Welcome back. I hope you all got a chance to attempt this. What I'm going to do is I'm going to begin the implementation for the same. Okay, so what I need to do is I'll go over here, and here in resources, I'll create a new XML file. Okay, so I'll say new XML file. I'll say application IOC, and this will be for loose coupling example, right? So I'll have this entire name over here. Okay, this is added. We'll need some boilerplate code. I'll copy this boilerplate code. I'll go over here. I'll paste it. Okay. So this is done. Now what we need to do is we need to have the beans created. All right. So what I'll say is bean ID. Okay. And I'll just get rid of this. We don't need this. Okay. There is no need of property also to begin with. Okay. So this is simply the bean definition that I'm going to have. Okay. We can remove this. So I need a bean to be created. Now, whose bean I'll create? I'll create the bean of the provider. So we have database provider, new database provider, and the web service data provider. So you can see web service data provider, user database provider, and new database provider. Okay. So what I'll say is I'll say over here com.loose.coupling. Okay. Am I referring to the right package? com.loose.coupling. Okay, one second. So it's better that I replicate this package, right? So this is the code that we created for loose coupling example. Okay, so what I would do is, or what I would prefer doing is, I would like copy this entire thing. I'll go over here. I'll try to paste this, and I'll paste it to this directory. Okay, one second. So I'll copy this. Okay, where will I paste it? I'll say com.ioc, and I guess the coupling package will be automatically added. You can see it's added. Okay, so we just replicated this com.ioc.coupling. This is our new package where we are going to make the modification. So we have the original code intact. Okay, we are not touching the original code. So I'll say com dot, I'll say IOC dot coupling dot, and let's say we want to say database. Okay, so we'll get the user database provider. Okay, and we'll call this bean as, what are we calling this as? We'll say this as user data provider, like so. Okay, I'll hide this. This is done. Okay, this is the definition. I need to duplicate this. Okay, let me duplicate. So I'll copy this, come over here. This is another bean now. Okay, now instead of user data provider, what I need to do is user database provider is done. I need to have new database provider. Okay, and here instead of user data provider, I'll say new over here, like so. You need to give the right names and you need to make sure that you're referring to the right classes. Okay, now here coupling dot, I have web service data provider. Okay, and here I'm going to say web service. So I'll say web service data provider. So I'm having the bean name same as the class name, just the first letter is in small caps. Okay, that's the difference. Okay, easy to identify. So there are three implementations of user data provider, right? And we have all the three implementations being added here. Now, what we need to do over here is I need to create bean. Okay, now I'll create 3 beans over here. Why 3 beans? So I need to have 1 bean. So there are 3 implementations, right? So I'll have 3 beans of user manager. Okay, so let me go to user manager. So here in the user manager, let me close others. Okay, and let me open this. Okay, so here in the user manager, okay, I need the instance of user data provider. Now user data provider is an interface and it has 3 implementations, right? So if you take a look at the list of implementations, there are 3 implementations that it has, right? So what we need to do is we need to have 3 beans of user manager with each implementation, because during runtime we might need any of the implementation, right? So what you can do is come over here, you'll say bean, I'll say ID, and here we'll have a ID shortly, we'll have class also defined, and here I'll make use of constructor argument. Why constructor argument? Because we are having constructor in the user manager class. Okay, so here constructor arg, and I'm going to have reference over here. Okay, so this is the structure that I'm going to use. I'll copy this structure because we are going to replicate this 3 times. So here in place of ID, I'm simply going to say user manager. So we'll add user data provider. Okay, so user manager with user data provider, something like this. Okay, what is the class? Okay, so the class is com dot IOC dot coupling dot user manager. This is the class. Okay, what is the reference over here? Okay, so reference is this. So user data provider. Okay, so I will be copying this shortly, but let me replicate this 3 times. If this is replicated, now I can copy this here and I can paste it over here. This is done. Okay, now I need to have another implementation, com.ioc.coupling. Let us say new database provider. Okay, and I'll say user manager with, instead of user data provider, I'll say new database provider, something like this. Okay, and in place of reference over here, I'll say with user data provider. Okay, not this one, but it's this one, new data provider. Okay, just be sure that you are mapping the right ones over here, otherwise it will be a mess. Okay, now here I can say com.ioc.coupling.user manager again. Okay, sorry, this one will be user manager here. This one won't be, because we are creating an instance of user manager. Okay, and we are passing in the constructor reference of new database provider. Okay, so this one also will be user manager, and here I can have what should be the name, web service. So user manager with web service provider. Okay, service provider, something like this. And here it will be web service data provider, something like this, right? So we have 3 beans created with 3 different implementations. Perfect. Now let us head over to app or loose coupling example over here. Okay, this was our main file. I can refactor this class here. I can rename it to IOC example. Okay. So I can say IOC example, refactor. Okay, this is also refactored, right? And yeah, this is done. So now if you come over here, what we need to do over here is we need to load the XML and we need to get that XML to work. Okay, so first I'll start with application context is equal to new class path application context. So this is how we have loaded all the time. So if you go to any of the examples here, okay, this is how we have loaded all the time. And you can copy this code from here or you can write it from scratch. Okay, up to you. Now over here, we need to pass in the XML file. Okay, this will be the location of the configuration file. Okay, so to avoid any errors, I'm simply going to go over here, refactor, rename, and I'm going to copy this entire XML name. And I'm going to come over here and paste it. Okay, so far so good. We have this done. Now what we need to do is here, I'll say, okay, I don't need to create an object here. So I'll comment this. Okay. Now if you come over here, we need the instance over here, right? So what I need to do is user manager with TP. So instead of creating object this way, I'll duplicate this line. Instead of creating the object this way, I'll say is equal to, okay, and I'll say context dot get bean. Okay, we need to get user manager with user database provider, right? So I'll come over here, user manager, okay, with user data provider. So this is the one, and I'll copy this name. I'll come over here, I'll paste it over here, okay, and I'll cast it. Done. Let us run and let us see whether it works. Let us see this. You can see this is working fine. We have only changed one implementation or one call over here. Okay, so we are not instantiating object, but we are getting it as a bean over here. You can see. Okay, and I can even move this to the new line so that you get a better visibility. Okay, it's a simple code. Here also we will like duplicate this. I will comment this like so. Okay, and here I'll copy this. Okay, I'll take this to the next line. Okay, and here I need a user manager with web service data provider. So user manager, this is new database provider, user manager with web service data provider. So I'll copy this and I'll come over here, I'll paste it. Okay, does this work fine? It should. Yes, it is. You can see. Okay, now I'll do the same with this. So here also I'll duplicate. I'll comment these two lines here. Okay, and here I'll let me copy this entire thing. Okay, and I'll head over to the new line and I'll paste it, something like this. Okay, and now here we need user manager with new database provider. So I'll just paste that over here. Okay, if you run this, it should work absolutely fine. You can see like how we are able to make use of a Spring container to get it to manage our objects. Okay, so I'm going to just remove this commented code over here. Okay, all the commented code. So yep, like this, and this one as well. Okay, so we have achieved and we have finished the challenge. So we were able to make use of Spring container and Spring features to implement inversion of control. So now what is happening over here is Spring is managing all the objects for us and we just need to request the objects. We don't need to manage them. Okay, So I hope this was useful and I hope you were able to solve this by yourself. If you were not able to, that's absolutely fine. Like I said, the goal of this challenge was to get you a little bit hands-on and not expect the right answer. Getting hands-on is really important when you're learning to code. Remember. So I hope this was useful and I hope you all enjoyed this example. So now it's time that we talk about auto wiring and understand what it is and why is it needed. So far, what we have been doing is, with the help of XML, we have been, I won't say managing, we have been defining the dependencies, right? So earlier, we used to create the objects and manage the dependencies within the Java classes. But now what we are doing is we have a XML configuration where we tell what is dependent on what. So here, for example, you have this bean car specification, and this is added as a dependency for the bean with car class. Okay. So you are specifying the dependency over here. Okay. Now Spring Framework has this amazing feature called auto wiring. Okay. And this is a feature that automatically resolves and injects dependencies between beans without requiring explicit wiring definitions in XML or even in Java configurations. Okay. So here we are having the wiring definitions. Like we are telling that, hey, this bean needs this dependency. Okay. But here, imagine this. So Spring knows that, hey, you have this car class, okay, and it has this object of type specification. So it can also figure out, right, that, hey, this dependency is needed. So I should actually be providing this during runtime so that the application runs. And that is what the process of auto wiring is. And this way of wiring dependencies based on predefined rules and the types of beans is known as auto wiring. It's completely auto wired. It's one step ahead than what we have been doing. Now, when you talk about auto wiring, there are different types in which beans can be auto wired. Okay. So first understand this. For auto wiring to work, you need to have two classes two classes. Here I have two classes and one is dependent on other. So car is dependent on specification. Okay. And now auto wiring can be implemented in three types. It can be implemented by type. So here, like the type of object is specification. The Spring, we won't inject. Spring would inject the bean based on its type. Okay. And that is what auto wiring by type. Then we have auto wiring by name. So here we have the object name or the attribute name, I should say, the class member variable name. And then we also have the bean name, right, which we create over here, like defined using ID over here, right? So this can also be used to auto wire. So this is known as auto wiring by name. Then you have auto wiring by constructor. So it will match the constructor arguments of bean. So here we have a constructor argument as specification. So it will use this constructor to inject beans, and that is known as auto wiring by constructor. Okay. So there are three types. One is auto wiring by type. So this is a type. Auto wiring by name. This is a name. And auto wiring by constructor. All right. So this is something that you need to understand. Now, auto wiring simplifies a lot of stuff. Okay. It is one step ahead of what we have been doing. It brings in a lot of efficiency in development, wherein you don't have to manage specify the dependency. In fact, we are not managing. We are specifying the dependencies and we are telling Spring Boot that this is how it has to be managed. But actually, if you take a look at the code speaks for itself, right? Spring can automatically take a look at the code and auto wire things. Okay. So that is the benefit of auto wiring. The disadvantage over here, I would say, is with XML configuration, you have good control. So you can specify the reference and all of that yourself, having full control in your hand. But when you pass on the control to Spring Framework, you lose a bit of control, okay, which has its pros and cons as well. Okay, so that's auto wiring. I hope the concept of auto wiring is clear right now, and I hope this was useful. So now it's time that we talk about auto wiring and we understand auto wiring by name in a hands-on way. So auto wiring, like we know, is a feature in Spring using which dependencies between the bean is resolved on the fly. Okay. And when you say auto wiring by name, the dependency is resolved by name. All right. Let us see how this works. So we already have an example in place where we had done constructor injection. So here we had done constructor injection to get the dependency resolution. Okay, so here if you take a look at this particular package here, we have class car, which needs the type of specification as a dependency over here. Okay, so car is dependent on specification, and specification is an independent class that stores the specifications of the class. Okay, how is specification injected into car class? It is injected via this constructor. Okay, and here if you see in the constructor injection.xml, we had injected this using this particular tag. Okay, which means we were telling Spring that, hey, this bean is dependent on this and this is how you are supposed to inject it. But what would happen with Autowiring is the dependencies would be figured out by Spring automatically. And since we are talking about Autowiring by name, we are going to see how name plays a crucial role here. Okay, so what I'm going to do is I'll create a new class over here. Okay, I'll say com.example.autowire.name. Okay, dot car. So this is the class that I'm creating in com.example.autowire.name. Okay, and I'm having a very descriptive package name, a very long one, just to keep it very verbose. Okay, so later on if we refer, we know that, hey, this package contains the files which show the example for Autowiring by name. Okay, I'm going to create this and the file would be created over here. Okay, now what we need to do over here is we can type in the code manually, or what I can do is I can go to the constructor injection package and I can copy all of this. Okay, I can move all of this to this package. And I'll say override for all. Okay, I'm getting this pop-up, add files to Git. So I have this version control system configured, and that is why I'm getting these pop-ups. So I'll just say add over here. Okay, and what I also need is an XML file. So I'll just replicate this constructor injection file because that is the closest that we have over here. And I'll call this file as Autowire by name. So we know, okay, this particular file has that particular config. Okay, and let me collapse everything now. No, actually I should close all the tabs here and I should open all these files here, right? Because these are the files that we are going to work with to see this particular example. Okay, now what we need to do over here is first thing, we need to load Autowire by name over here. Okay, so I need to say Autowire by name.xml. Okay, we are getting this particular bean over here and we are displaying the details. Fair enough. Now if you come over here, okay, we need to make a little bit of configuration changes. So what we are doing here is we are creating this bean of car specification, and then we are like having this bean created which is of car, and then we are mapping it with specification using the constructor injection. We don't want to use constructor injection right now, so I'll get rid of this. Okay, also I need to update these classes, so they are pointing to constructor injection package. I need to update them to car.example.autowire. Okay, so what is the package name? I forgot. com.example. Okay, so it's not car dot, that is why I was not getting suggestion. So it's com.example.autowire.name. Okay, this is the package name. So we have the fully qualified class name right now for the car, as well as the specification. Okay, so we are done. Okay, they're pointing now to the right classes. Okay, now what I need to do is here, when we are creating the bean, I need to say that for this particular bean, so car bean is having the dependency on specification, right? And when I pressed space over here, so you can see, let me close the tag over here. And when I pressed space here, you can see there are so many properties that you can add, attributes. So I can select Autowire and it has a lot of values that you can assign: by name, by constructor, by type. So since we are talking about by name, let us select by name over here. Okay, now how by name would work is it would go to car class. So since we are saying whatever dependencies car class needs, please autowire them by name. Okay, that is what this statement means. Okay, so what Spring is going to do is it will go to car class. Okay, it will see, all right, it has one class that it needs, one class object. Okay, and since we have specified by name, it is going to look for specification over here. So it will take a look at the name because we are saying by name, and it will try to find a matching bean by this particular name. Okay, it will try to find a matching bean by this particular name. So keep this in mind. And do we have a bean matching this particular name? We don't have, right? This bean is called as car specification and not specification here. So I'll take this name here and I'll paste it over here and I'll save it. Okay. And here, then what it will do is, in order to initialize this, it needs to initialize. It won't need a constructor. So constructor we had because this is an example copied from Constructor injection, right? So we don't need a constructor because it won't be used. This initialization would be done by a setter. Okay. And we will add a setter for the same. Okay. So I can say setter and we'll add a setter, something like this. So let me show this to you in action. So I'll go over here. I'll say run. Okay. And you can see you got Toyota and model is Corolla. Okay. Now let me experiment with this code. Okay. So before even experimenting, let me explain this to you once again. Okay. So I'll give you a step-by-step explanation as to what is happening over here. So first of all, the configuration is looked up. Okay. So here you say, hey, load the configuration. Okay. So configuration is looked up. Spring says, okay, there is this bean that has to be created. Fine. I'll create this bean. These are the properties. I'll set the property. Okay. It sets the property using what? Setter. So in specification, it calls all the setters. Okay. You can even validate this. So you can say system.out.println setter called make. Okay. If you run this, you'll see setter being called, right? So those properties are being initialized with the help of setter. Okay. You can validate it by adding print statements anywhere you want. Okay. So this bean is done. All right. Now what happens? It looks for the second bean definition here. It says, all right, there is one more bean that I need to manage. This is the class definition. Okay. And I have to auto-wire it by name. Okay. So all the dependencies that this particular class needs, it has to auto-wire by name. And what it means is the name of the bean should be same as the property name within car class. So it goes in the car class. It sees, okay, this specification that it needs and the name is specification. How do I match it? So the developer has said by name. So I'll try to look for bean that matches this name. Do we have a bean that matches this name? Yes, we do have. So inject it over here. How it will inject? Okay. So since the car bean has the property name specification of type specification here and auto wiring is configured to be by name, Spring will try to find the bean with that name specification and it will inject it. And when injecting, it will call the setter method. Okay, keep this in mind. So by name, when you try to use auto wiring by name, the injection happens with the help of setter. Okay, and this way it will be initialized and then the next step happens. Okay, so next step are defined over here. So we get the car object and then we call display details. Okay, now let me experiment with this code. So let me first comment the setter. We said that setter is being used over here, right? So what happens if I don't have a setter? You can see over here, we got an exception that toString was called over here. Okay, so here, if you see, we are calling display details, right? And display detail is converting the specification object to string and specification is not initialized. Remember, we have commented the setter over here, right? So it's not initialized. So specification is null. And that is why we are getting this error, right? So setter is important. If you're getting null, you must have missed the setter. Okay. If you come over here, I also mentioned that when you say auto wiring by name, the name should be equal to the attribute name or the class member name in the car class. Okay. So let's say what happens if I change the name. So if I add 1 over here. Okay. Now the name is not matching, right? This is specification 1 and this is specification. So if I run this, you'll see it is again null. So even though we have a setter, it is still null because it is not able to find the bean. So if the bean is not found, it is not being injected. Okay, so I'll remove this, I'll run this, and you'll see it runs. Now let us add one more scenario here. So let us say you have one more bean of the same class. Okay, I duplicate this statement. Now your bean names are same. Okay, if you run this, you can see we got such a big stack trace. Okay, so you cannot have one more bean with this particular name. Okay, so what I will do is I'll change this to 1, and I'll change the values also to 1. Okay, so if this bean is being picked up, we'll know the value will be printed as Toyota 1 and Corolla 1. Okay, so now if you run this, you should get Toyota and Corolla. Why? Because this is specification. If I make this as if I make this as specification 1 over here. So let me rename this as specification 1. Okay, specification 1 and specification 1. Okay, and let me run this now. What would happen? Okay, it's still picking so it did not make use of the second bean, and the reason is because I need to change the setter name as well. So it should be set specification 1, right? So if I run this, okay, you can see Toyota 1, Corolla 1. Okay, so what is happening is specification 1 has this particular setter and it has this particular class member, okay, which is being used over here in display details. So everything is specification 1 including the setter. So be sure to change the name of the setter as well. Okay, only then it will work. So you can see how this bean is now being picked up. Okay, so this validates our statement that when you say Autowire by name, the name is being matched with the bean name. The name of the attribute that you have defined is being matched with the bean name, and whenever it founds the matching bean, it will make use of setter to initialize it. Okay, that is how autowiring works by name. So this is how this example will work. Okay, I'll now just revert, or I don't need to revert the XML. In fact, what I'll do is I'll just revert this particular part. Okay, so that it picks up the first bean itself. Okay, if I run this, it should work fine. Okay, so feel free to experiment more and understand this even more. Okay, how this is working. These things are really important, and this will form the base going further. So now it's time that we talk about autowiring by type. Now with autowiring by type, Spring will inject the bean based on its type. And if let's say you have two classes, and if one class depends on another class, then Spring will look for a bean that matches the type and it will inject it into the class that needs it. Okay, let me demonstrate this. So we already have this car example, which is car and specification. So what I'll do is I'll copy these files straight away. Okay, I won't make code changes in this current files because we can refer it later then. I'll paste it in the Java folder and I'll paste it under I'll say example .autowire I'll say type. Okay, since we are talking about type. Okay, so it won't be dot, it would be slash. Okay, it won't be dot, it would be slash. So just keep that in mind because you're copying it right now. And yeah, I'm done. I think I'll add this to my version control, which I have configured locally. Okay, so here you will see all the files coming over. Okay, autowiring by type. I also need to have a XML file in place. So I'll say autowire by name. Instead of name, I'll say type. Okay, so I just copied autowire by name and I pasted it at the same place. And it's asking me to create a copy and I just added type. Okay, there's a pop-up whether I want to add this file to my Git. I'll say add. Okay, so far so good. I'll just open all the files so that we can work on them. First thing, I'll make sure that I'm pointing to the right class in my autowiring by type package. So I'll say type over here. Okay, I'll select type and then I'll change it across everywhere. Okay, here as well. Okay, and here I'll then say instead of name, I'll say like this, I'll say type. something like this. And yeah, we are done now. Okay, so what we need to do now over here, instead of by name, we need to say by type. So I'll say by over here and by type. Okay, now what is happening is here we have two beans, right? And when you are saying by type, what Spring will do is it will go to car class, it will see, okay, it needs type of specification over here, and it will look up for the bean that is of type specification, and then it will inject that. Okay, it won't look for name and all. So here now the problem is we have two beans with specification, so there will be a confusion. So if I run this, okay, let me run this. If I run this, you'll see that we get a very long error. So you can see over here, error creating over here, no qualifying bean available of this particular type, expected single matching bean but found two, specification and specification 1. So it's clearly telling you that, hey, if I'm matching by type, I need a single bean of that particular type to be available. So for that, I need to comment this, okay, and I'll run this again, and now it should work without any hassles. Okay, so this is how autowiring by type works. So autowiring by type, always remember, it looks for the type, and it also needs to find a single bean with that particular type. Name and all does not matter. So if I change this to specification 1, this is different from the class member name. If I run this, it will still give me the result. Okay, this was not true when I made use of type over here. Sorry, not type, but name over here. So if you say name over here, it won't work. Okay, it will give you null. That's the problem. Okay, so because name is not matching now, right? If you go over here, the name is not matching. It's specification 1. But the moment you say by type, so if I press Ctrl Z and if I change this to by type, and if I run this, you see it's working fine. So that's how autowiring by type works. Let us take a look at autowiring by constructor. So what I'm going to do is I'm going to duplicate the car class example over here, and I'm going to specify the path as com/example autowire and constructor. Okay, I'll add this to my version control, and we have the files here. Okay, I also need to duplicate the XML so that I have it in place. Okay, constructor, something like this. Okay, so this is done. Okay, what I will do is I'll just open all the files that I need to work on. Okay, and I'll close this sidebar. So here now, first thing, I'll just make sure I point to the right package. Okay, so I'll make use of constructor everywhere. Okay, because we are talking about autowire by constructor. And I also need to make sure I load the right XML. Okay, so I'll say constructor here. Okay, something like this. Yeah, so this is done. Now what we can do is we can run this and let us see the output. So you can see it runs right now, but we have not changed the autowire type. So I'll say, okay, if you take a look at the options, you have by name, by type, you have default as well as no. I'll specify constructor because we are talking about autowire by constructor. If I run this, I get null. Why I get null? Because I'm saying that I want to autowire by constructor, but I don't have a constructor within the car class. So if you go over here, I have a setter. Okay, I need to add a constructor. So using that constructor, the autowiring will be done. And this tells you that if you're trying to autowire by constructor, you need to have a constructor defined as well. And you can see over here, this works perfectly fine. Okay, setter actually is not needed in this case. Even if I comment this out, something like this, and if I run this, it will still work. You can see. So this is how autowiring by constructor works. Now, if I try to duplicate this or I don't need to duplicate, I will just uncomment this. If I simply uncomment this and if I try to run this, there are now two matching beans, right? So I can have specification here. Let me run this. You can see we get an error. Why we got an error? Because there are two matching beans, specification 1 and specification. So this also tells you that, hey, if you are like doing this sort of auto wiring by constructor, you need to have only one matching bean. Okay. And if you run this again, it works. So this is how auto wiring by constructor works. So let's begin talking about annotations in Java. So what are annotations? Now, annotations in Java provide a way to add metadata to your code. So it's a feature using which you specify some additional information about your code. And this additional information is known as metadata. Now, this metadata can be used by compiler, development tools, or any runtime environments, frameworks, libraries, and so on. Okay. So what are annotations? Simply put, you are telling more about the source code that you have written. Now, talking about history of annotations, I don't want to go into depth, but annotations were introduced as a feature in Java 5. So long back, and today they play a crucial role in modern Java development. Okay, so you can write some piece of code like classes, methods, variables, and then if you want to add some more information, or if you want to give some special instructions about what the code is and how they should be used, what they should do, then you can make use of annotations. Now, if this is a little bit confusing, then don't worry. Everything will be clear when we create and write our first annotation. Okay. So one point I would want to mention over here about annotation is that annotation is not the actual code that does the work. It is just some information that you are pointing out to whoever you want to, like framework or runtime environment and so on. Okay. You have already used annotation if you're coming from Java background. So if you're coming from Java background, you must have seen this annotation @override. Okay. So annotations start with @ symbol. And override is an annotation above the method to tell something to the Java compiler. So you are telling, by making use of this annotation, you are telling the Java compiler that, hey, I'm providing my own version of the method that is already defined in the parent class. And I know that this method exists in the superclass, but I want to do it my way in this class that I'm creating. And that is why you specify this override annotation. And this override annotation also helps you to make sure that you are actually overriding the method correctly. So if you make any mistake in the signature, you will immediately get an error that, hey, the signature does not match the one in the parent class. So here, override is not a piece of code. It's some information that you're specifying, like a metadata that you're specifying about the code that you are writing. Okay. Now in Spring, annotations are used extensively to simplify configuration and runtime behavior. Okay. So you will be using annotations a lot, and I'll talk about some of the commonly used Spring annotations. So for example, you have one annotation called component, and this annotation simply marks a Java class as a bean or a managed component. Okay. You also have something called as Autowired, using which Spring will autowire the dependency with the matching type. You have qualifier. So if there are multiple matching types, you can specify a qualifier as to which bean should be matched over here. Value is used to inject property values into your beans. Repository is used to define the data repository. It's a specialized version of the component annotation that we see on the screen. You have service, which is also a specialization of component annotation, and it is used to indicate that this particular class is providing business services. Controller, it is used to create web controllers that will handle HTTP requests. You have request mapping. Okay. Then you have Spring Boot application. So these are the different annotations that exist in Spring. Okay. And we'll be making use of all of these annotations at some point in time. So if you're not clear of what this annotation means or what that annotation means, don't worry. We'll do everything hands-on. So for now, I just wanted to introduce you all to annotations and just give you a refresher. I hope you are clear on this concept. So now it's time that we talk about components and ComponentScan. So let's first begin talking about components. So what is a component? Now, component in Java refers to a class that is managed by Spring's IOC container. Now, Spring IOC container is Spring Inversion of Control container, and this is a container that manages the Spring beans. Okay, so components are building blocks of the Spring application, and they will have certain functionalities that they'll provide within the application that you're building. Now, you have been hearing about Bean all the time, right? And listening to component, you will be like confused. Okay, this is also managed by Spring IOC, and Bean is also managed. So think of it this way: component is like a bean only, but it's specifically designed to be auto-detected and configured from class path scanning. Now, what does that mean? So scanning is something that you'll understand in some time. But for now, just understand that component is a special kind of a bean that is designed to be auto-detected. Okay. And it's a bean only. There is hardly any difference, but it will be auto-detected rather than we manually defining everything in the XML file, right? So that is what component is. Now, question is, how can you define components in Spring, right? You know how you can create beans, but how would you define components? So to create components, you will make use of XML, and you can even do so using annotations. So these are the two ways in which you can create components. Using XML, you can make use of this kind of a syntax, okay, where you are saying, I want to create a bean and this is a class, and this is something that we have done. But using annotations, you can make use of the component annotation just above the class definition or the declaration. And this particular annotation will mark the class as a Spring component. Okay, so this is how you simply mark a class as a component. And also make a note of the import statement at the top. This annotations you're getting from the org Spring Framework stereotype package. Now, what is component scanning? So component scanning is a feature that helps to automatically detect and register beans from predefined package. Okay, predefined package paths, I mean. So you will create components, all right? Now, Spring needs to know where it needs to check for component and register itself, okay? Because see, I told you that component is a bean that auto registers itself, right? Now, in order to tell Spring that, hey, I want you to scan this particular package specifically and look for all the components that I have declared over there and register them as a bean. So you need to explicitly tell Spring, and this explicit telling you can do with the help of component scanning. Okay, so it's a feature that helps you automatically detect and register bean from predefined package paths. Okay, and who will be defining these package paths? You will be defining as a developer. Okay, so you can enable component scanning in one of the packages, something like this. So you can say context component scan. You can make use of base package, and you can say base package is this. So within this particular package that you have specified, all the classes will be scanned along with the sub packages. So if there are classes in the sub package, they will also be scanned. Okay, everything will be scanned within this particular package, including sub packages, and they will be registered as beans. Okay, so this is about components and component scanning. I hope this was clear and useful. So now it's time that we start creating our own components and even understand how we can do component scanning. So what I'm going to do is in IntelliJ, I am going to head over and I'm going to create a new class. Okay, I'm going to create a class in, let's say, com.example.componentScan. Okay, and I'm going to name this class as employee, let's say. So we are taking a new example. Okay, it's asking me whether I want to add this file into Git. I'll say yes, I have it enabled. Okay, so I have this particular employee class. All right, now what I would do is I'll have certain fields over here. So I'll say private integer employee ID, something like this. I can even have private, instead of integer, I'll have string. I can say first name. Okay, then I'll have last name. Okay, and then I can have salary. So what I will say is private and double, I'll say salary. Okay, now what I want to do is I want to register this particular class as a bean. Okay, so one way is I have the XML definition, okay, like we have always done here in the resources folder. So let me also get an XML file. Okay, so let us call this XML something. Okay, so what I'm going to do is I'll call this as ComponentScan. So since we are talking about components, something like this. Okay, ComponentScan demo. Okay, and here we have defined bean this way. Okay, so whenever we define it this way, what happens is the bean is registered with this name, but I'm going to skip this particular definition here. Okay, I'll just comment this out. Done. And now what I can do over here is I can say, and now what I can do over here is after commenting, I can come back to employee and I can register this as component. So you can say component, you can see the suggestion, it's from org Spring Framework stereotype. So I'll get this. Okay, and we are done. Yeah, this is our bean here. And now what I can do is I can even add some getters and setters. So let me add some getters and setters over here. So I'll say getter and setter. We'll get getter and setter for all. And then in the end, I'll also get a toString over here. Okay, so let us override toString. Okay, so we are done with this particular class. We have a component being registered. Now what I can do is let me create app.java here. Okay. All right, so this is app and this is going to have a main method. So we need a way to call our class that we have created. Okay, and I can just get the code from elsewhere. So let me open this app and let me copy this. Okay, and I'll come over here. I'll just paste it over here. Okay, so this is done. Now over here, we need to update this. So instead of Autowire by XML, okay, I can say component scan demo.xml. Okay, this is done. And over here, I need to get the employee. So I can say employee is equal to new. Sorry, not new. I have to say context.getBean. I can say employee like this. Okay, and we are done. I will have to add a semicolon. I need to cast it. So either I can cast it over here or I can even specify one more parameter. Okay, employee.class. So this will also work if you don't want to do casting. You can just specify the class like this, and I can say employee dot toString. Okay, something like this. Okay. All right, so this needs to go into system.out.println and I need to move this line here. Okay, we are done. Let us try running this and let us see what happens. Okay. All right, so I get an error. Makes sense. A silly syntax error that I made. Okay. All right, I get an error. Okay, so we are getting an error. It says no bean employee available. Okay, so this is interesting. And this is helping us understand the importance of ComponentScan. So you saw that I defined the ComponentScan demo.xml. Okay, but I commented out the bean definition. I have added component over here. So this is a bean that needs to get registered. Okay, but I need to tell Spring which packages it needs to look out for. Okay. And depending on what I specify over here, it is going to scan those packages for all the component definition. So I need to tell over here context colon. Okay, I need to say, so right now I'm adding context and it's not working because I realize like this particular XMLNS. So this does not have context. So what you can do is you can Google for ComponentScan XML here, something like this. Scroll down to the official Spring documentation. Here, if you scroll down a bit, you will see a XML format here. Okay, so this is how you can specify the component scanning. Okay, and here you can see this context is being added over here. Okay, this is what we want. So what I would do is I can copy this entirely here. Okay, and rest all we have. Okay, so I'll come over here, I'll paste this, and here you can see this syntax context colon component scan, and you have to specify base package. Now what is our base package? So base package is com.example.componentscan. Okay, so this is it. This is a package, right? We want everything to be scanned within this particular package, right? So this is the package. And what we are telling Spring is, hey, look for all the components within this package. So what Spring will do is it will start searching for all the components and it will find this one and it will register this as a bean. And let us see if this is true. So you can see this works absolutely fine. There are no issues as such. Okay. Of course, we are not initializing the values right now, which we'll be doing in some time. But over here, we are getting null, null, and all the default values. Like for integer, we are getting 0, and for double, we are getting 0.0, which is okay. But the point I'm trying to make over here is we have literally just added one annotation here. Just see the process. One annotation, okay? And we have instructed Spring that, hey, scan these packages for components, okay? Now, one more thing I would want to mention is here with this annotation, you can even specify the name with which you want this to be registered. Okay, so if I say employee, it will work. Okay, why? Because we are fetching employee over here. Okay, and by default, what it will do is it will take the class name and it will remove this capital letter and it will convert it into small case and register it with that name. Okay, so by default also it's getting registered with the name employee. But if I add employee 1 and if I run this, it's not going to work. You can see no beaned name employee available. All right, you can see. And if you change this to employee 1, only then it will work in this case. You can see. So if you want to have any sort of custom name, you can of course do it with the help of this kind of like mention over here. Okay. So that's about the component and component scan. I hope this was useful and I hope you have some clarity as to how these things work. So we have been able to create component and we have been able to scan the component with the help of this XML. Now the thing is, whenever we run, we are not seeing any values. Now how do we inject any value into our properties that exist within the component? And if you want to do this with the help of annotation, the answer to your question is the value annotation. Okay, so here you can make use of value. You can see this annotation appear from org Spring Framework Beans Factory Annotation. Okay. And here it allows you to specify any value that you want to have. So this will be the default value. So I can say hello, for example, and I can run this. You can see hello is being initialized instead of null over here. Now you can do a lot more. Instead of just adding a string over here, you can add any sort of string. Okay. If you want to, you can add any sort of value, but if you want to have a system property, for example, so you can add that as well. So you can like copy this. Okay. So let's say I want to add my Java path. Okay. So you can say something like this, java.home. Okay. Now this will assign the system property into last name over here. You can see last name. This is my Java path home. Okay. And you can inject values like this. Okay. If you want to inject a expression, you can make use of something like this. You can say value, and within value, you can say hash, and you can specify any sort of expression. So 4 into 4, something like this. And wait a minute, let me align this a bit. Okay, so it's okay. So you can see if you run this, you should see 16 into salary. So it's a computed value that is coming in from here. So you can make use of value annotation, okay, to inject values into beans. And this can help you a lot with some initial values. Okay, I hope you're clear with the value annotation and I hope this was useful. So now it's time for us to transition from XML to annotations completely. Okay. So far, we have been making use of XML over here. Okay, so we have this XML file where we are telling Spring as to where it should scan for components. So this is the XML file. Okay, here we are telling Spring that, hey, you need to scan for packages over here. Okay, and we need to get rid of this XML now and move to completely annotation based process. Okay, so what I'm going to do is we are going to come over here, and just to let you know, I've already created a new package com.example.componentscan.annotation, and I've duplicated the class over there. Okay, so that the earlier changes are intact and we don't touch them. Okay, so we'll be playing in this particular package now. What am I going to do is I am going to have the configuration provided via a class instead of an XML. Okay, so here we are providing the configuration from an XML. We'll create a class. Okay, let me create a class over here, and we'll call that class as app_config. Okay, so I'll say app_config. Okay, this is a class created, and this will be the configuration class. So this class won't have any methods of field, because the purpose of this class is just to have the configuration. And how are we providing configuration? We are providing configuration using annotations. So I'm going to say @. You can see the number of annotations that appear, a lot of annotations. Now you can slowly type component and you'll see ComponentScan over here. Just pick this up. Okay, within bracket, you can like specify a lot of things. So the moment you add bracket, you can see like there are so many things, value, base packages, and so on. So we'll go for base. Okay, and I'll say base packages. Okay, how to get rid of this? This pop-up is not going. Okay, so it will be base packages, something like this. Okay, and here I'm going to say car.example.componentscan.annotation. So this is a new package that I've created, okay, which has the file, right? So we have defined the annotation. Now what we need to do is we need to tell Spring that, hey, you need to refer to this class for all the configuration, and that we have to specify using configuration annotation. Okay, so this is one more annotation that enables you to specify that, hey, this class is a configuration class and you can load the configurations from here. Okay, so you can see we are adding two annotations over here, which is perfectly valid. And now we don't need this ComponentScan demo.xml. Okay, so I'll just close this. And what we are going to do is we are going to not make use of ComponentScan demo.xml. Okay, so we are going to update this thing over here. So I'll tell you how we are going to update now. Okay, now the thing is we made use of class path XML application context to get the type of context over here, which is of type application context. Now application context over here is an interface, as you can see, and it has different implementations. One of the implementation is class path XML application context, which allows you to load the configuration from the XML. But if you want to load the annotation based configuration, you have to make use of annotation. You can see config application context. Okay, and then here you need to specify the class. Okay, I'm going to get rid of this and I'm going to say app config dot class. We are done. Okay, and let us try running this, whether it runs fine. Okay, so we get an error. So the error says there is no bean named employee available. Okay, there must be some mistake that we are doing. We are trying to get employee properly. We are loading the app config properly. Let's come to app config. So here the package is com example, and here we have mentioned car example. Okay, this is a mistake. So make sure you add your packages correctly. I had by mistakenly put up car over here. It's com.example componentscan.annotation. Run this. So whenever you get bean not found or something like this, just check the package names and just check what is referring to where. Okay, so if you just take a look around, there might be some typo or mistake that you must have done. So even if you're typing this, I would recommend copying and not typing. So you have to just copy package from here and paste it. Okay, don't type it, because you might make some mistakes like typos or something like that, and then you might get error and you might wonder why you're getting that. Okay, so just be careful about that. But as you can see over here, you can now see that we are making use of app_config.java, which is annotation based configuration. Okay, and we are not making use of XML based configuration that we had earlier. So we have transitioned completely from XML to annotations, and you can see that over here. How did we do it? We did that with the help of this configuration class. which is app config. And we did that with the help of a implementation of application context, which is annotation config application context. Okay. So that's about how you can transition and eliminate XML completely. If you are enjoying this course so far, then you should also check out our complete full stack development mastery roadmap, the details of which are given in the description below. It comprises of multiple courses that you would have access to. Also, you'll find these details on the website as well. All right. The website is embarkx.com, and I would highly encourage you all to check this out to become a pro developer. Welcome, and let us begin talking about auto-wired annotation, and let us understand why is it needed. So I'll just open up this particular project over here, okay, that we were working on. I'm going to need these classes like app config, and even the employee. So I'm going to copy these classes. I'm not going to make any changes over here, and I'm going to paste them in the root Java folder. And I won't be pasting them exactly in the root, but I'm going to paste it in /com and then /example and autowired /annotation. So we are talking about autowired annotation. Just make sure you don't conflict with autowire.constructor, autowire.name. Okay. I'll just say okay, and I'll say add, and you should have the classes over here. Okay. I'll close everything else and I'll just open these files. Okay, I'll close the sidebar. Now, what is auto-wired annotation? So auto-wired annotation is a kind of annotation that allows you to signify automatic dependency injection. Okay, so whenever you make use of this annotation, you are telling Spring to automatically inject dependencies into your Spring managed beans. Okay, so let me give you an example. So let us say there are two classes that are dependent on each other. So over here, we just have employee. Okay. We don't have a class that is dependent on employee or any class that employee is dependent on. Okay. What I will do is I'll add a new class over here. Okay. So let's say we have a manager, manager.java, simple. And what I'm going to do is I'm going to have employee over here. Okay. And I'm going to create a dependency employee, something like this. Okay. So I have this dependency. Now I want this dependency to be injected automatically. Okay. So what I can do is I have, let's say, let me add a constructor. So I have a constructor here, which is of type employee. Okay. What I can do is I can come over here, I can say auto-wired. You can see this auto-wired dependency being, not dependency, auto-wired annotation being added. Okay. So you will add this over here and you can see it being imported and it being added over here. Okay. Now what will happen is Spring will take a look at what this particular class needs. So it needs employee. So what it will do is it will automatically inject the bean of type employee. So if it has a bean that it is managing of type employee, okay, then it will automatically inject that. Okay, so this is what auto-wired is going to do for you. Okay, and we can even have, let me generate toString for this. Okay, so I'm just generating toString for manager, and what I'm going to do is here I can simply print in the manager information as well. Okay, so let me do one thing. Let me also register manager as the component. So what I'll do, I'll come over here. I'll say component. Okay, this is a component. We come into app, and here we are getting the employee, which is good. I'll also get a manager. So manager is equal to, not new, context dot get bean. I'll say manager, comma, manager dot class. Okay, and here instead of employee dot toString, I can have manager dot toString. Let us run and see. Okay, we accidentally ran a wrong class, so we need to run this one from here. Okay, so we get an error. Okay, so bean name employee is expected. Okay, So one issue is we copied the source code here. Okay, 1 second. So we copied the source code from here, but we did not change the class name. So it has to be this class name. Sorry, not this class name. This is package name. I'm sorry. So we have to replace the package name here and then run it. And it should work absolutely fine, as you can see. You can see like this is the employee, and this employee itself is a manager. And this is a dependency that is being injected with the help of this auto-wired annotation. You can see how magical this was. You just specified one annotation. You're telling Spring Boot, sorry, not Spring Boot. You're telling Spring Framework that, hey, auto-wire the dependency here. And what Spring is doing is it's so smart that it will simply get the bean of that particular type and it will just inject it. Now, this kind of injection, you are making use of Constructor injection over here. Okay. So one question that you like student always asks me, okay, and you might also have, do you need a constructor over here? Okay. So the answer is you can remove the constructor. Okay. Let me remove and show it to you. So what I'll do is I'll just comment this out. Let's say we don't want constructor. Now the question is, if you run this, you'll get null over here. Okay. This won't have any value. You can see manager is null, but you can do things without constructor, which means you can specify this annotation even above the field. And if you run this, you'll see it's injected now, right? So what is happening over here is this was doing constructor injection and this is doing field injection. Okay. So you can even inject fields. So field injection is normally used when you have lots of fields that you want to be injected, right? And you want to do you don't want to have a constructor, but you want to do it with the help of field injection, and it will reduce the boilerplate code and it will make your class look a little bit cleaner and concise. Okay. But normally constructor injection is what is recommended. Okay. Because it gives clarity as to what is being injected where, and it helps, right? So normally constructor injection is preferred over that of the field injection as per the best practices. Okay. But as you can see, auto-wired annotation is really helpful and you can see your beans being injected automatically with the help of, or I should say by Spring IOC container. Isn't this useful? So yes, it is. Okay, for me, it's really useful. So I hope this lecture was useful for you all and I hope you enjoyed learning about auto-wired annotation. So in this particular video, I want to talk about qualifier annotation. So let me give you a scenario. You're working in a large project, and normally in a large project, what would happen is you can have multiple beans created of the same type. Okay. Now, whenever you have multiple beans of the same type, let's say in our case, if you have multiple beans registered in Spring container with the same type employee, okay, then what would happen is if you make use of auto-wired, Spring container is going to be a little bit confused and it might throw an error that, hey, there are two beans registered of type employee, which one you want to consider. So in that particular case, you have the liberty of making use of qualifier and also specifying the name of the bean. So here you can specify employee. So I want the type this with name this to be injected over here. And if I run this, okay, you should see the output normally. And if I change this to something else, you're going to get error. Okay, you can see no qualifying bean of this type available, right? So since we have given a name which does not exist, that is why we got this error. But qualifier is normally used if you have multiple beans registered with the same type but different names. So in that case, you can make use of qualifier. I hope you're clear about what qualifier is and how you can make use of it. So it's time that we evaluate our progress and do a quick review as to what we have learned so far. So we started our journey by understanding the basics of web development. We understood what web is, what are web framework, how web works, and so on. Okay. Then we spoke about Spring Framework and we understood how Spring emerges as a powerful tool that can help us build robust Java applications. Okay. We discussed the need of Spring in modern Java development and how it addresses the challenges that are normally faced when building complex applications. And during this process, we understood concepts such as coupling. We understood what is tight coupling, loose coupling, and so on. We also spoke about configuration, and we understood how, with the help of Spring, you can provide configurations. We spoke about concepts such as dependency injection and inversion of control, which is IOC. Okay. We also spoke about how you can make use of XML and annotations to provide configurations and configure different components as well. Okay. So this was a journey so far, and we have come very far in this. Now it's time that we talk about a few things. So first thing that we understood over here with Spring Framework is that you need to do explicit bean configuration. Okay. Yes, explicit bean configuration is needed, wherein you need to manually configure your beans, whether it's through XML file or annotations. Okay. Of course, you can do away with XML file. In XML file, you need to add the bean tag and all. But with component scaling, the configuration reduces a bit, wherein you just have to specify the location as to where the scanning needs to be done to get the component. But still, there is some configuration involved, right? You are actually doing it explicitly, right? Now, this can be verbose and complex for large applications, right? There is no embedded server so far in our application. Okay. So our application does not include an embedded server. So tomorrow, like if you want to deploy it on a local server and test it as to how your application is running or responding on server like Tomcat or Jetty, it can take a few steps that you need to do manually to set up the deployment, right, on a local server. Okay. So this is one thing. Another thing is component scanning. So like I said, you need to do explicit configuration to enable component scaling, and this can be cumbersome because if you have lots of packages and if the components grow in numbers in your application, you might make errors or mistakes. Okay. Boilerplate code. Okay. So we need to write boilerplate code still in our application to set up basic configurations. Okay. Like if you need to do a database setup, we will have to do some configuration over there. Okay. You will have to write code to authenticate your users. So authentication is very normal when it comes to Spring Boot. Okay. And if you want to authenticate your users, so authentication is very normal in today's web development. Okay. Every website that you see has authentication. Every website has security. Now, these are all standard features, right? Every web application needs them. Every web application needs a database, okay? But if you need to create a web application using Spring, you need to configure all of this manually, okay? So there is a lot of boilerplate code involved to implement security, to implement authentication, to implement standard things like database, okay? So that's what I mean by boilerplate code. So this is the review so far, and we'll understand how Spring Boot comes into picture and how it takes away all these hassles and how it simplifies the development of web applications in an easier, faster, and more efficient way. All right. So I hope this was useful. Let's start talking about what is Spring Boot. So Spring Boot by definition is an open source Java-based web framework which is used to create standalone production grade applications which are built on top of Spring and Java. So it's a Spring based web framework, okay, and it runs on Java. And also one thing to note over here that it's open source and freely available. Now, what is the benefit of using Spring Boot? Like, why would you use Spring Boot over Spring? And what is the advantage that Spring Boot gives you? So, here's the difference between Spring and Spring Boot. So, with Spring, there were lots of things that were involved in setting up, configuring, writing boilerplate code, and also deployment of the app. Okay. So of course, when it came to building apps before Spring, like before Spring was invented or created, there was a lot of boilerplate code and Spring reduced that to a lot more extent. Okay. So a lot of boilerplate code was eliminated with the help of Spring. But with Spring Boot, the boilerplate code was further eliminated. Okay. So with Spring Framework, you had a lot of things available readily, But still, there was some configuration to be done. There were a lot of steps that were involved in setting up and also in the deployment of the app. For example, if you're building an application, a web-based application, you're building it on your local machine first, right? Because that is a development environment. Now, to test your application, you need to have a local server running on your system. So with Spring, you had to set up a local server wherein you deploy that app and you configure the app that you're building with that particular server. And you had to do this for every application you build. Of course, a lot of things were automated and pre-configured, but yes, there were some things that were left out. And that is where Spring Boot came in. So Spring Boot offered a set of pre-configured components and defaults, and it eliminated the need for a lot of boilerplate code that was involved in setting up a Spring application. It went a step further. So you can think of this as, so analogy that I can give you over here is of a Maggie. Okay, so if you're building or if you're cooking Maggie, let's say, okay, and how do you cook a Maggie? Like you have a sachet with a pack of noodles and you just put it in hot boiling water, you boil it for 2 minutes and you're done. So that is pre-configuration. Okay, it's pre-configured. So you didn't have to do anything. You just had to get a pot of hot boiling water and you had to tear the packet and empty the noodles into the boiling water, and that is it. You're done. So the packet had a lot inside, so it was pre-configured, okay, to be cooked this way. All right. So it reduced the effort at your end and you could enjoy your meal quickly. Okay. So this is one analogy that I could give you when it comes to Spring Boot. Spring Boot operates in a similar way. So you just get the source code, you create the Spring Boot application, okay, and you can run it with a single click. It's that fast, okay. It's ready to be built, okay. So you can think of Spring Boot as Spring Framework plus a lot of pre-built configuration plus embedded server, okay. So Spring Boot is equal to, you have Spring Framework, pre-built configuration and embedded server. So for running the application, like I said, you need a server, okay, and Spring Boot has that pre-configured, okay, and embedded within it. So when you create a Spring Boot project, you don't have to set up a server where you would be testing your application and running locally. It's all embedded. You have to just create the project, okay, write some source code for your application and run it, and it will run on the embedded server, okay. Also, there is a lot of pre-configuration that goes, which we will talk about, okay. So this is Spring Boot, okay, and it eliminates the need for a lot of boilerplate code like I mentioned right now. It levels up essentially the development that you are doing with Java and Spring, okay. So if you're using Spring Boot, you are much more faster. You get to focus a lot on business logic rather than doing these daily tasks like embedded servers, and these are all manual things which can be taken care of. You as a developer can focus on the business logic, which is really, really important. Let's now talk about the components of Spring Boot. So the number one component is Spring Boot starters. So what are these Spring Boot starters? So these are a set of convenient dependencies, okay, that can be included into your application, okay. Like you can say these are ready to use ingredients, okay. So for example, if you're building a web project or if you're building a REST API, you know you will need to create some REST endpoints, okay. And for that you have a starter. If you're building a web application, you have a web starter, which signals that you're building a web application and all the configuration that is related to a web project is pre-configured and included. Okay. If you're building a database driven app, you have a starter for that. So whatever is needed for a web application that interacts with the database is pre-configured into that. So you have to just include that and it's done. So this is what Spring Boot starters are. It's a library or a shop, you can say, which has a lot of components ready to be included into your Spring Boot project to accelerate your development. The next step or the next component is auto configuration. Now, Spring Boot auto configuration attempts or it configures automatically your Spring application based on the dependencies that you have added. So if you have added, let's say, a dependency for database, so all the configuration that is needed for database is automatically taken care of. So Spring Boot determines that, hey, this particular application has database related dependencies. So guess what? It's going to use database. So I need to configure things that are needed for database, and it will take care of that. You don't need to do manually. Okay, you just need to set some properties like username, password, or the host where it can find the database and so on, but they are very minimal, and Spring Boot does the heavy lifting over here. So that's auto configuration. So based on like whatever dependencies that you have added in your application, it configures or auto configures things for you. Okay, you don't have to deal with the configuration manually. So this reduces a lot of hassle. Then you have Spring Boot Actuator. Okay, now this is one of the non-functional features. So if you're building a Spring Boot application, you would need a way to monitor that application. You would need to gather some metrics like how many requests are coming, is the application up and running. So all these kind of monitoring things, these won't be the requirements that your client is going to tell you. Nobody is going to tell you these requirements. From the developer standpoint, these are needed for you. Okay. So Spring Boot provides Spring Boot Actuator, which you can add to your project, and it will enable the production ready features like monitoring your application, metrics gathering, tracing your HTTP request, and so on. Okay. So that's Actuator. Then you have Embedded Server. So Spring Boot includes an embedded server like Apache, Tomcat, Jetty, and it allows you to run your application as a executable standalone jar file. Okay, and this eliminates the need of you deploying your application on a separate server and testing it. Okay, so it simplifies the process. Then you have Spring Boot DevTools. So DevTools is a set of development tool that enhance the productivity during application development. So for example, if you make some changes, you might want a automatic application restart or redeployment, like live reload of static resources and so on. You might need some better logging or enhanced logging for faster development. So all of this is provided by Spring Boot DevTools, and you can include it into your project. Let us talk about the advantages of Spring Boot. So number one advantage is it's standalone. Now what I mean by standalone is it can be started using a command java-jar, and it does not need to be deployed on a separate web server. Okay, and it allows you to get quickly started, offering rapid application development. Okay, then it provides you with starter code. Okay, now like we discussed, startup projects enable you to get started quickly. It takes care of configuration and dependencies that are predefined, okay, and that are needed for every web application. It needs less configuration, okay, which means like since the configuration is taken care of by Spring Boot itself, there is very less need or no need to do configurations manually. And because of all this, it enables a company to reduce the cost and the application development time, and it helps them to go to market really, really faster. All right. So these are some of the advantages. And because of these advantages, a lot of developers love Spring Boot. And some of the reasons are it's Java based, which is one of the most popular programming languages out there. And it's fast and easy. Yes, it enables faster development and it's easy to use. Comes with an embedded server. It has various plugins and a lot of boilerplate code and configuration is avoided. All right. So that's Spring Boot for you. Thank you. Let's talk about Spring Boot architecture. So Spring Boot has a layered architecture wherein one layer will communicate with the other layer. And there are a few layers or a few tiers that exist in a typical Spring Boot web application. Following are the different tiers. We have presentation layer, we have service layer, and then we have data access layer. Let's talk about each one of them individually. So what is presentation layer? So presentation layer presents the data and the application features to the user. This is like the front end view, and this layer is the layer wherein all the controller classes exist. Okay, so what does controllers do? So controller accepts the request from the user, validates the inputs that the user has given, and passes it to the next layer, which is the service layer. So like I said, presentation layer does the job of presenting data and information to the user. Then we have the service layer, wherein the business logic resides in the application. Now, things such as evaluations, decision making, processing of data, all of this is done at this particular layer. This layer also does the job of interacting with both presentation and the data access layer. So this layer sits in between and does the job of communicating with both the layers, and they are frequently being called by presentation layer, and they will call the data access layer frequently. Now, what is data access layer? So data access layer is a layer where all the repository classes reside, and these repository classes are responsible for interacting with the databases, like performing the operations to read, retrieve, save data. And underlying databases can be any database, like it can be relational database or like NoSQL databases, but it is a job of data access layer to access the data and interact with the database lying under it. Okay, so this is how a typical Spring Boot architecture looks like. So these are the three different layers in which the application exists. Now let us take an example. Let's say we are building a library management system. So we will have a browser from where the user will be interacting with the application, since it's a web-based application. So this is our application, and user will be sending a request, and that request will be handled or received by the controller. Okay, so user interacts with the controller. Controller, it will take a look at the request and it will forward it to the service layer. Now, service layer classes interact with the repository classes, and repository in turn interact with the database. Now, service layer is the layer that will be responsible for all the logic that is related to our business, which is a business logic. So that will reside in the service layer. Controller and repository will do the job of interacting with the user and interacting with the database respectively. Then once the data has been fetched from the database by the repository layer, okay, what repository layer will do is it will pass the data to the service, and eventually the data will flow to controller and user will see it in his or her browser. So this is a flow in which a typical Spring Boot application works. The request comes through the controller from the user, then service, repository, and then it travels reverse back to the controller. All right. So this is a typical architecture of a Spring Boot application. So that's about this class. I shall see you all soon. Thank you. So let us start talking about Spring Initializer and create a Spring Boot project. So what is Spring Initializer? So I'm here on this website, start.spring.io. Now, this is a website for Spring Initializer, which is a tool that enables you to generate or create a Spring Boot project. So if you're using free version of IntelliJ IDEA, which is the community version, that particular version does not have the ability to create a Spring Boot project. Okay, so you can create a Spring Boot project using IntelliJ if you're using the professional version of IntelliJ. But for free version, it does not have that ability. So for that, you need to make use of a free tool, which is openly available over here on start.spring.io. Now, this particular website asks few questions about your Spring Boot project. And when you hit generate, it will generate the complete project structure, which you can then import in your IntelliJ IDEA. okay, and you can start coding over there. So this is a really handy website. You should bookmark this website because you will need this website every now and then if you are working consistently with Spring Boot, and provided you don't have the professional version of IntelliJ. So what I would say is you should head over to this website, Spring Initializer, which is here, start.spring.io. You need to select the project. So here it will ask you a few questions like, what sort of project are you creating? So I'm creating a Maven project. So these are different build tools that exist. So I'll use Maven for proceeding with this project. Okay, you can use Gradle if you wish to, but I'll choose Maven. Now language, of course, will keep Java selected. And here it is asking you for the Spring Boot version. So here there are different versions of Spring Boot that are available. Okay, and you can choose any one of them. Now here you will see some versions that are labeled as snapshot over here. So you can see 3.2.0 snapshot. Okay. Now using the snapshot version of Spring Boot is generally not recommended for production environments. And the reason is snapshot means pre-release versions. Okay. Which means that these are still under development and they have been opened up for preview. And they might be incomplete, they might have bugs and other issues. Okay, so they are intended for testing, development purposes if you wish to try out some new versions of Spring Boot. Okay, but snapshot version is generally not recommended. So I'll be selecting this version, which is a non-snapshot version. You have other version too, which is 3.0.8, but I'll choose the latest one. Now, another thing is when you see this lecture or this website, when you visit this, you might see a different version, like different numbers over here. Okay. Now that is perfectly fine. You can choose whichever is latest available because these versions keeps on changing as Spring Boot keeps on pushing new versions out there. Okay. So don't worry about the changing version numbers over here. Okay. So you can select the Spring Boot version starting with 3. Now 3 indicates you're using Spring Boot 3 version. Okay, so just make sure you're selecting the version that starts with 3. Okay, so once you've selected the version, here this particular tool will ask you for some project related information. Okay, now it's asking you for group. Now what is group? So group is nothing but the package name of the project. Okay, and this is usually the reverse of the domain name. So the default one here is com.example. So I'll say com.embarkx. Okay. So this is a website that I have. And then you have artifact. Now artifact is nothing but the name of the project. So the project name I can say as first spring here. Okay. You can enter any name that you wish to. Okay. So this artifact name and this name will also get updated over here. Okay. Now description is the description of the project. So you can say first project for Spring Boot. Okay, and you can see the complete package name over here. Okay, so this package name is automatically generated based on the information that you have given over here. Okay, so this is about the project metadata. Now there are a couple of fields more that have been pending. So here you can see packaging. So applications can be packaged as jar file or war file. So I'll keep jar as selected. Okay. And here it's asking you which version of Java you wish to use. So I'll keep Java 17 version selected, which is the long-term support version or the LTS version that is available. If you have some other version of Java that you wish to use, you can change it over here. That is perfectly fine. Okay. So this is about the configuration over here, the project configuration. Now on the right hand side, you see the dependencies. All right. Now if you click on add, you will see some dependencies that exist. Okay. So you can see like Spring Boot DevTools, Lombok, Spring Boot Web. So if you're building a web application, you need to select the Spring Web, and what this will do is this will include everything like RESTful applications, like things needed for Spring Embassy and an Apache Tomcat, as well as the embedded container inside. So whatever is needed for you to build a web application, all of that will be included if you select this particular part. So you can scroll through and take a look at different dependencies that exist over here. So there are different categorizations, like you have web, then here you have developer tools, then here you can see template engines. This is Timeleaf. Okay, so if you are like writing some Java templates which are server side and you want to display HTML into the browser, so you can use Timeleaf. So the dependency will be included. You have security related aspects and so on. So you can scroll through, you can see JDBC. Okay, so if you select this and this, like everything related to the database will be configured. Okay, and you can take a look at the different kinds of databases that you can use over here. Okay, you can see MySQL driver, PostgreSQL, Oracle, and so on. Okay, you have NoSQL options as well, which is MongoDB, Redis, and so on. Okay, so there is a lot. You can just go through this list. Okay, so this is about the dependencies. So what we are going to do is we are going to search for web, since we are building the web application. Okay, now if you scroll up, this is what will be added. Okay, Spring Web here. Okay, and then you can click on Explore. So if you click on Explore, it will show you the project files that it will be creating for you. Okay, so you can take a look at the structure here. You can see pom.xml. You can see this is the entire structure. You can just take a look. Okay, so you can either copy, download, or I'll say close over here. Okay, and also one more thing I wanted to talk about is, so not this one, but this one over here. So this is a mode, like if you prefer a different mode. Okay, this is like, I don't know if it's useful for you, but you can, like, if you wish to have a dark mode, you can use this. All right. Then after doing this, you need to hit generate. So when you say generate, this entire project structure will get downloaded onto your system. So just hit generate and save this particular file on a particular location wherein you will be creating the Spring Boot project. All right. So that's about Spring Initializer for you. So just make sure you have downloaded the project structure over here from the Spring Initializer website and you have saved it to the desired location. So I have saved the file over here at this location of my choice. Now what I'm going to do is I am going to unzip it over here. So I'm going to say extract here, and this is going to extract and give me all the files within this particular zip file in this particular folder called First Spring. And this is what my project name was. Now we need to start using this project into IntelliJ. And for that, we need to import this project into IntelliJ. So what I need to do is I need to head over to IntelliJ. So when you open IntelliJ for the first time, you will see this welcome screen. And if you have created any projects earlier, you should see a list of recent projects over here. So you can say open over here. So I'll click on open. You can navigate to the location of your choice where you have this project saved. So I have this project saved over here. You can see First Spring. I'll select this. I'll say OK. Now it will ask you whether you trust this particular project, because what is going to happen is IntelliJ is going to run the source code that exists in this particular folder when importing. So it's asking you if you trust this particular project and whether it has been downloaded from the valid source. So yes, we trust this project. So I'm going to say trust projects in courses Spring Boot. So I'll trust all the projects that I have over here and I import in future. Okay. Alternatively, you can preview in safe mode if you don't trust it, but I'll say trust the project. And what is going to happen is it is going to open this particular window here. Okay. And it is going to load the entire project. So here I see a welcome screen where it's welcoming me to IntelliJ's new version 2023. Okay. It's giving me some tour over here. Okay. And here it also has some tutorial, like on the right side, some customizations. And here there is some processing that is happening. You can see. So it's updating this particular repository. So it is fetching, in short, all the dependencies. So if you click on this, it will say updating Maven dependencies. So I'll tell you what this means in a while, but what happened here is we had specified all the dependencies when we created the project. Like we specified web, Spring Web, and you can see the dependency here. So this was the dependency that we specified. Now to get this dependency onto your project, there has to be some download that needs to happen. And that is what the download that was happening here at the bottom. Now you have some customization options over here, like you can customize it to dark mode. Okay. So, so Windows is blocking some features over here. So I'll say allow. I trust IntelliJ. Okay, so you can change it to dark mode. Dark mode is brilliant. You can keep the system mode. Okay. You have an option to have a compact design or a clean one. You can choose whatever you want. I'll keep this to light mode. Okay. And I'll just say finish setup. Now you have some updates over here, okay, as to what's new in IntelliJ 2023. So you can go through this, okay. But let's explore the project structure over here, okay. So you can see the entire project structure on the left-hand side over here, okay. Now you can see some folder, like you can see the SRC folder. So this is a folder where your source code resides, okay. So you have main, and under main, you have the Java folder. So this is a folder where you can see like all your Java files coming up, okay. And you will have this folder here, this file here, which is the application file. This is by default created, okay. And you have this package name, which you had specified on the Spring Initializer website, okay. So this is the Java source code. This is where all your Java source code will reside. Now, if you expand resources, you will see static folder and templates folder and a properties folder. So resources folder is where all your HTML or like user facing code will reside. Okay. Then you have something called as test, and here is where all your test cases will come. Okay. So you can define test cases under this test folder. And then you have pom.xml. So you can see this pom.xml. This is one of the important files when it comes to Spring Boot. And within this file, it's an XML file. And within this file, all the dependencies of your Spring Boot project have been specified. So you can see all the configuration things over here. So you can see this is Spring Boot version that we chose on the Spring Initializer. Okay. This is the group ID, the artifact, the name of the project, the description, which version of Java we are using, and the dependency that we had selected. So this is a starter web. So when we said Spring Web on Spring Initializer website, this is the dependency that was added. And it's a starter project, as you can see. And what is starter project? So it has a lot of pre-built configuration for a specific purpose. So since we have specified the purpose as web, so everything that is needed for a web application is included in this dependency. Okay. Now you also have over here on the left hand side a folder, which is a huge folder, and the folder says external libraries. Now this is a folder which has all the libraries that are needed for the project. Okay. And if you scroll through, you can take a look at the different libraries that exist. Okay. So this is about the project structure. Now let us talk about this file over here, which is first Spring application. Okay, so this file has some source code in it. All right. And you can notice this annotation over here, which starts with the @ sign. Now, what does this annotation mean? Okay. So this annotation specifies that this particular application is a Spring Boot application. Okay. Now, if you go to this class which defines this annotation, so if I press and hold Control on Windows, or if you're on Mac, you can hold Command. And if you hover mouse on this, you'll see it being converted into link. And if you click on this, you will see that it's an interface. Okay. And this is a class. And you will also notice that this class has 3 more annotations. Okay. Which is a Spring Boot configuration. So this is one of the annotations. Then you have enable auto configuration, and then you have ComponentScan. Okay, so Spring Boot configuration tells that this is a configuration file. Enable auto configuration tells that you need to enable auto configuration for this particular project, wherein the configuration should be done automatically. And then you have ComponentScan, which allows you to scan for packages that exist. All right. Okay. So these are the three main annotations within Spring Boot application, and that is what we have specified outside over here. So I'll close all of these class files here. Okay. Now, if you go to pom.xml over here, okay, if you scroll up, you will see this Spring Boot starter parent. Now, this is one of the projects that is by default included in our application. And this particular project provides the default configuration for our application. Okay. And it inherits the dependency management from Spring Boot dependencies. All right. So that's all we need to know about this boilerplate code that has been generated by the Spring Initializer website. All right. So that's about this class. I shall see you all soon. Thank you. Let us talk about dependencies in Spring Boot. So dependencies refer to the external libraries or modules that your application would need to function properly. Okay, and Spring Boot makes use of Maven or Gradle build systems to manage the dependencies. So if you remember, when creating the project, we had selected Maven over here. Okay, so this project is created using the Maven build dependency, and we have a pom.xml file over here. Now this is a file that manages all the dependencies that are needed by our project. Now if you want to add more dependencies, you need to add the tags over here. So this is a tag dependencies which tells that all the dependencies are to be specified over here. This is one dependency and this is another one. Now, Spring Boot provides a wide range of starter dependencies, which are curated collection of commonly used and commonly needed by developers for a specific purposes. Now, these starter dependencies makes your life easier as a developer, and by including this, you can reduce a lot of boilerplate code. And you don't have to manage these individual dependencies manually. You need to make use of pom.xml file. For example, when you say, like, I need the Spring Boot starter web dependency, everything that is needed for a web application to function is included. Okay. Now, apart from this Spring specific dependency, you can also include like third-party dependencies that your application might need. And this could include some database connectors, some certain frameworks that you might need, or some libraries that you might need to do caching, or some other functionality that you might require. Okay, but by making use of this pom.xml file and specifying the dependencies here, you can easily save time and effort. Okay, so I'll show you. You can go to like maven.org. So since we are using Maven, I'll say search Maven. Okay, so you will see this link over here, search.maven.org. Now this is a link for Maven Central. And it says, if I zoom in, it says official search by maintainers of Maven Central repository. So you can discover different Java packages and you can even publish your own. So I'll go to this Maven Central over here. And you see the welcome screen over here. I'll say close. Okay. Now what you can do is you can search over here. So I'll say Spring Boot Dev Tools. So this is a simple search that I have performed and you get to see all the search results over here. Now you can see over here Spring Boot Dev Tools. Okay. And you can see the different information like the latest version, when the latest version is published, licenses, and all of that. You can click on this and you have this tag over here. Okay. So if you're using Apache Maven, you can like copy this and you can paste it in your project. Okay. You can even change this to Gradle, or if you're using any other build tool system, you can switch it to that. Okay. And you also have a Maven pom.xml file. You can see over here. This is an example file that you can take. But if you just need to add it to a Spring Boot project, you can just copy this and add it to pom.xml under the dependencies tag. Now you can go over here and choose the versions as well. You can take a look at the version. Okay. So if you need a specific version, you can go and check that out. So I will go to 3.0.0 and it will open up the page for that. So this is the version and you can see the version number over here, which is specified. Okay. So this is about the Maven search repository. Okay. Now if I go back here. So here on the home page, you will see like some of the most popular packages that have been consumed by developers in last 90 days, some of the namespaces and so on. So you can like just play around with this if you wish to. Okay. And you can like just explore this a bit. Okay. Now you will also see some dependencies over here. So this is the official website of Spring Initializer and you're seeing some dependencies that you can add over here, and whatever you add over here. So I added Docker Compose. You will see the pom.xml being generated over here, like for that. Okay. Now, what is the difference in getting the dependency from Spring Initializer and Maven Central? So Spring Initializer provides a curated list of commonly used Spring Boot dependencies that cover a wide range of use cases. Okay. However, it may not have every single dependency out there that exists within the Spring ecosystem. So there will be scenarios wherein you might want something and that does not exist on Spring Initializer. Okay. So you could go for Maven Central then, or you can visit the official website of the provider for that as to how you can include it. Okay. But there will be several reasons as to why that dependency is not included on Spring Initializer. Okay. And some of the reasons that I could think of is the number one is it's a custom or a lesser known dependency. Okay, so Spring Initializer focuses on what is popular and what is commonly being used in the Spring community. So if a dependency is relatively new, niche, or it's less commonly used, then it may not be included over here in this particular list. Okay. Also, start.spring.io, like the Spring Initializer website, includes the latest stable versions of the dependency. Okay. So if a specific version of the dependency is not considered stable, then it may not be included in this list. Okay. And also this particular website is maintained by the Spring team and the community. Okay. So they gather a lot of feedback from the community, and based on the community feedback, they make sure the dependencies are available. So these are some of the factors as to why you might not find all the dependencies over here. But if you don't find anything over here, nothing to worry. You can like head over to Maven Central and search for whatever you are looking for. Or like I said, you can go to the provider's website. All right. So that's about dependencies in Spring Boot. So now is the time to start creating our first API. So we'll create a very basic API and we'll understand how things work with Spring Boot. And this will be a RESTful API endpoint. All right. And for that, we are going to need a controller. So I'm going to go to the project structure. I'm going to scroll up, collapse everything. And here I'll go and I'll say new. I'll say new Java class and I'll call this as hello controller. And I'll press enter. Now, if you have Git configured, you will see this pop-up. And if you don't have, you might not see this pop-up. So I have Git configured on my local machine, and that is why it's asking me to add this file to Git. So I'll say don't ask again and add. Okay. Now here in this controller file, I'll start writing some code. Okay. And I've called it hello controller because we are going to just create a simple hello world API. All right. I'm going to first say @REST controller. So you can see this auto suggest, and this is the annotation, which means that we are ready to use Spring MVC to handle web requests. All right. So we need to specify this annotation if you're building a REST API. And now we are going to create a GET request. So I'm going to say public. I'm going to define a method. I'm going to say string hello. So it's a very simple API, and I'm going to return hello world. You can return anything you wish to, but I'm returning a simple string. And now here we need to, so we have this method here. Now how do we map this to the URL? So we can map this using annotations. So we have defined this as a controller using annotation. We will use another annotation, and you will say @ and I'll say get, since this is a get mapping. So I'll say get mapping. Okay. And as a parameter, I'll specify hello, like so. Okay. So what we have done is, if any request comes on our domain with /hello, so domain name /hello, we will be invoking this method, or Spring Boot would be invoking this particular method and executing the logic that we have written inside. All right. Now let's take a look at REST controller. So REST controller annotation is a specialized version of controller annotation. So you have this annotation as well, controller, okay, which you can see, right? But I'll delete this, and I'll delete the import as well. We don't need the import. But REST controller annotation is a specialized version of controller, and it combines two annotations, controller and response body. And if you wish to see, you can hover on this and press Control or Command. So if you're on Windows, you will press Control. On Mac, you will press Command. And I'll go into this annotation, and you will see you have controller and response body annotation here. So there are other annotations as well, but these are two main ones. Okay. And this indicates that this class is responsible for handling HTTP request and return the response in the form of a RESTful representation. Okay. So that is what this specifies. And we have specified this annotation, which means that we have informed Spring Boot that this is what we are doing over here. And then we have this get mapping annotation with which we defined a get mapping. All right. Now what I will do is I will run this particular application. So I'll go to first spring application.java, and I'll say run over here. So this will run the Spring Boot application. Okay. You can see some processing happening over here. Okay. And you will see this message here. Tomcat started on port 8080. All right. So on your local machine, this application has been deployed on the Tomcat web server, which is now available on port 8080. So what you need to do is we will switch over to our web browser. So here in the web browser, I'll say localhost : 8080. So of course, we'll get an error over here. So we get an error, white label error page, and this is a default error page that Spring Boot provides. And it says that there is no mapping defined for this particular URL, which is correct. So we have defined the mapping for /hello. So we need to access that. And you can see over here, we have the first Spring Boot application working up and running in our browser. All right. So what we did, we literally just wrote some small piece of code, a very basic method, and we have the output in the browser. All right. So that's how you can create a Hello World API using Spring Boot. Let us understand how our API worked. So when we executed our application, okay, we have kept our application running so far. So if you want to keep accessing your application from the browser, you need to keep the application running and don't stop the server from here. So this is how you can stop the server, but don't stop if you wish to keep accessing the application. Now, if you scroll up here on the console, the number one thing, when you start the application, you will see this Spring banner that appears printed on the screen. Okay, and this is the first thing that you would notice. And this is a Spring ASCII art banner. That is what it's called. And you will also see the Spring Boot version being printed. Now, after you scroll down, you will see that our application is starting over here, and it indicates that the application is being started. Now if you scroll back, you will see the environmental variables are being set over here. Okay, so here we don't have any active profile. Okay, and it's using the default profile over here. That is what it says. Now what I mean by profile is you can set variables like environmental variables in application.properties file. You can define some properties over here. Okay, so we have not defined anything and we have not done anything over there. So it's picking up the default one. So that is a default property file that we have, and that is being picked up, and that's empty. All right, so environmental variables have been set. Now after environmental variables have been set, Tomcat server is being started. So you can see over here, Tomcat is initialized with port 8080. Okay. Now if you scroll down further after the initialization of Tomcat, you will see like servlet engine and everything is being initialized. Okay. And then the Tomcat was started on port 8080. All right. So this indicates that our application was ready to access. Okay. And then we went over to the browser and typed in the URL to access the API that we have created. Now what happened when you tried to access the API? So when you typed in this URL over here in the browser, like localhost 8080/hello, the request was prepared, and this is a GET request that is being prepared from the web browser, and it was being sent to this particular port number on this particular URL. And you have the Tomcat listening over there. Okay, you have your web application listening over there. And once the request was sent, the request was accessed by the controller over here. So if you come over here, you can see that we had defined this controller, and this is what intercepted the request, and it processed and executed the method over here and returned the response. So this was the entire controller action that happened over here. So if I disable this, if I hide this, so you can see this controller came into picture and it served the request that was being fired right from the browser. Okay, and the response was sent. Now when sending the response, this particular string was packaged into a HTTP response and it was shown onto the browser. All right. So this is what the entire process that happened. Okay. Now there is a significant amount of to and fro that happened, and it happened within a fraction of seconds. Okay. Now imagine if you have more layers defined, like if you have, this is a controller. Let's say if you have service and data access layer defined. So this all happens within a second. All right. So that's about how our application was executed. Let's talk a bit about how Spring Boot auto configuration works. So when you ran the Spring Boot application, you saw that there was a Tomcat server automatically set up. So this is one of the magics of auto configuration, and this magic is being done by Spring Boot auto configuration feature. So this was automatically configured, set up for you, and your application was deployed without you doing anything. We just created the project and imported it, and we wrote a simple controller function. Okay. The next thing I want to talk about is this dispatcher servlet that you see over here. So it said initializing servlet, dispatcher servlet. So dispatcher servlet is at the heart of any Spring MVC application, and it routes incoming requests to the appropriate controller methods. Okay. Now Spring Boot takes care of configuring this dispatcher servlet for you. It auto configures this servlet and it saves the effort of setting it up yourself. Okay. The next thing is the REST controller annotation. So REST controller annotation at the class level tells Spring Boot that this particular class is a controller, and it knows that it is a controller and it should handle the HTTP request. Therefore, it creates a bean for this. Okay. So a bean is nothing but an object that is being managed by Spring. Okay. So bean is created for this particular class in the application context, and it is being mapped to the controller. Okay. So this is all handled by Spring Boot. You just have to specify this annotation and tell Spring Boot that, hey, I will be defining all the endpoints in this particular file. Then we defined the get mapping annotation. So here in the controller class, Spring Boot auto configuration detects that get mapping annotation is specified for this particular URL, and it automatically executes or maps this particular method whenever you call this particular URL, and that is what we saw in action. Okay. So another thing that Spring Boot does for us is default error mapping. So if you access any endpoint other than what you have specified, so like we tried to access the root URL here. So you got this error page. Now this is by default generated error page, and this is pre-configured for you. Okay. It's a simple page. Now if you want to have a custom page, you can definitely modify this. Okay. But this is also one of the magic of Spring Boot auto configuration. Alright, so this is about Spring Boot auto configuration and how Spring Boot makes your life easy. Let us start talking about application properties. So in Spring Boot project, we saw this file application.properties, which exists under resources folder. Okay, now this properties file is used to do configuration in Spring Boot. So you get a pre-configured application with Spring Boot, which you can then customize by using this particular file and specifying the key value pairs. Now, what are the key value pairs that you can specify over here? So for that, you will head over to the browser and you can search for application properties Spring Boot. So I can say application properties Spring Boot. Now you will see this first link over here, which is the official link that I have opened. And this depicts the common application properties that you can make use of. Okay. Now you can see this is supposed to be specified in application properties or application.yaml. So .properties is one format, and then there is another format called YAML format. So if you wish to use YAML format, you are free to use, but we will stick to .properties. So here are the properties that you can take a look at, and this is the categorization of the properties on the left hand side. Okay, so now you can scroll down, and if you scroll down a bit, if I say Control F, I'll say server dot. So if I select server properties, you can see this particular property here, server dot port. So this is a property that is used to specify the server port. So when you executed the Spring Boot application, it was by default accessible on 8080 port. Now, for some reasons, if you wish to customize the port, you can do that by specifying this particular property. Now let me show this to you. So I'll head over to our ID and I'll say server dot port is equal to 9090. Okay, and I'll hit save, and now let me rerun the application. So I'll stop and rerun. Now if you check the console logs over here, you can see it's running on 9090. Okay, and if you go to the browser on 8080, if you refresh, you won't see anything. So it's like site cannot be reached. And if you enter 9090, like over here, you will see this error appear over here. Okay, and you can go to hello and you will see the endpoint working perfectly fine. So this way you can customize the defaults that you have got using this particular application.properties. Okay, so you can go over here and you can specify this. So I have some properties pre-written over here. So these are some of the properties that enable you to specify or configure a data source connection or a database connection. So you can say, so this is an example for configuring a database connection for MySQL database. Okay, and suppose you have a Spring Data JPA application which interacts with the database. So you can say the database URL is this, username is this, password is this, and you're specifying DDL auto update. Now what this means is you are telling Spring Boot to connect to this database, okay, and This last property is telling Spring Boot to automatically create or update the database schema as needed. Okay. So with update, if there are any changes, it will simply update and create. Now, one important thing to note over here is that properties defined in the application.properties file can also be overridden by command line arguments. Okay. So you can run your application by command line, Spring Boot application. So since we are using an ID, we are not doing that. But you can specify the argument as server.port is equal to 7070 while running. And this will make sure on command line the 9090 is overridden and it runs on 7070 instead, even though you have specified 9090 in your application.properties. So this way you can make use of application.properties file, okay, to like configure some pre-existing configuration that has been given to you by default by Spring Boot. Okay. So this is about application.properties. Let us talk about how you can create a post request. So the first thing, I will remove this server.port property and I'll let my application run on the default server. Okay. Then I'll switch over to hello controller. So this is where we will be defining the post request. So we have a get request. Now post request is another type of request with which you can send some more information. Okay. So we have an annotation @get mapping to define a get mapping. Now what will it be for post? It will be post mapping, like so. And we will keep the URL same. So I'll say hello, like so. Now here I'll define the method. I'll say public, I'll say string, and I'll say hello post. So this is the method that will handle the post request. Okay. And here I'll return something. So I'll say hello. And let us return the name over here. Okay. And I'll add an exclamation at the end, like so. Now we are returning the name of the user or whatever is passed with this post request. Now where does this name come from? So we are getting an error right now that name is not defined. So we need to give this name as an input to this particular method. And this name should be accepted from this particular post request. So for that, I'm going to add an annotation over here. I'm going to say request body. So from the request body, give me string name here, like so. Okay. So in get, we did not have any parameters because get is just a method, like get is just a request call. Okay. But in post, you can send some data along with the request. Okay. So what we are saying is we are saying request body, and this request body annotation is used to indicate the request body that should be bound to the method parameter name. Okay. So with this, we are done defining the post mapping over here. Okay. Now what we can do is I'll rerun the application. But the question is, how do we access this using the browser? So we cannot access or we cannot execute a post request from the browser. And for that, we need a special tool, and a tool like POSTMAN could help us do a post request to our application. All right. So far we have created the post request and we have returned the response. Now it's time that we should see it in action. So after defining the post mapping, we need to now figure out a way to execute this. So it's not possible to execute this from the browser like we did for get mapping, because we need to pass some additional information with the request. And there are some special tools that enable you to execute post queries. So for that, we are going to head over to the browser and I'm going to search for POSTMAN. Now, POSTMAN is a tool that enables you to work with APIs. So I'll go to POSTMAN API platform and you can read and learn more about this particular tool. Okay, or what I'm going to do is I am going to straight away download POSTMAN. Okay, so I don't find the download link over here. Okay, so you have to go to product and you can say get started for free, and you will be taken to this page where you can download POSTMAN. Now it will automatically detect your OS, and since I'm on Windows, it's telling me to download for Windows 64-bit, or you can even try it on web if you don't want to install it onto your system. And this is what it will look like, the interface. Okay. So what I'm going to do is I'm just going to download this particular tool for my Windows machine. So as you can see, it's being downloaded. Okay. And it's been done. Now what I can do is I'll double click on this and I'll get this installed onto my system. Okay. So I believe we downloaded the portable version. Okay. So it didn't install, but it just directly launched, and I'm going to add it to my taskbar as favorites. Okay. So you can hit download button over here. Okay. And download the respective version for your operating system and get it installed. The installation steps are very, very easy. Like it's just like any other software with no complexity. Once this is installed, so I already have this installed onto my system. So once you launch this for the first time, you will see an interface like this. Okay. Now you can see on the left hand side, you have this pane which talks about history. And this gives you the history of all the requests that you have executed. On the right hand side, you have this pane to execute a request. And along with the request, you can pass in additional parameters, authorization information, headers, body, and so on. So a lot of information you can send along with requests. And this particular tool is just for working with the APIs. So what I'm going to do is I'm going to head over to 8080. I'll copy this URL and we need to write a post query. So I'll paste this URL here. I have get selected over here and I'll say send. So you can even run the get request. As you can see the output. I'll just zoom in a bit. So the output is hello world, and this is the exact output that you were getting from the browser. Switch this to post. Okay. And now here in body, you need to add some body. So I'll select body. Okay. The reason I'm selecting body is we need to send the request body along with the request. So I need to add a body. So I'll go to body. Under none, I'll say raw. And I can specify anything over here. So I can specify hello Spring Boot. Like so. And I'll keep text selected and I'll say send. And you will see hello Spring Boot. And you can see 200 OK over here. So after execution, the default status code that you get after successful response is 200 OK. Okay. And you can see the time 16 milliseconds and this is the data. Okay. So here you can see the history appearing as well. Okay. So even if you fire get query, so if I fire a get query, you can see the status code as 200. Okay. So the status code for both was 200. Okay. All right. And you can see the response generated as well. So you can make use of POSTMAN, okay, to play around with different API queries or different API requests, not queries. All right. And POSTMAN is pretty handy and it is being used widely. All right. So that's about how you can work with post requests with POSTMAN. Thank you. Hello everybody, welcome to this class. So in this lecture, we are going to do some setup related work with POSTMAN. Of course, we have installed POSTMAN. We are calling the APIs. It's working well. But there is some additional setup that I believe needs to be done. And if you do it, it would be beneficial for you. So what is happening right now is we are seeing this history tab and all the requests that we have created over here. Now, the thing is, we are not saving these requests. Okay, so if you close this, it is coming in the history format. Okay, so if I close all the tabs, it's coming over here in the history form. And if you delete Postman or anything happens, you have essentially deleted all these requests that you have created. And you might want to reuse these requests later on or whenever you are testing something. Okay, so what we can do is we can save these requests. Okay, now what I would recommend is you can say add to collection over here. Okay, you can see this button over here. Now, what is this concept of collection over here? So in Postman, you can save a request within collection. So collection is nothing but like a group of all the API requests within Postman. So within this collection, you can have like 10 API requests that have been saved by you, for example. Okay, and you can categorize API requests that you are saving in the form of collections. But you cannot add anything to collection right now. You need to create an account. So I would recommend you create an account over here. Okay, you can either click on this add collection, or you can say sign in if you already have an account, or you can say create an account from here. Okay, so it will take me to the browser over here, and I can say I can put in my email. So I'll say embarkxofficial@gmail.com, or instead I can just sign up using Google. Okay, so I'll just copy this email so that I don't have to type in again, and I'll say sign up with Google. I'll use another account. Okay, I'll add embarkx and I'll just sign up over here. So I've entered my password, and so basically you will be prompted with this particular pop-up here wherein you would be asked to accept the license. You can read through the license if you wish to, but I'll say accept. Okay, and we'll wait for the redirect, and it will show you this pop-up now. So do you want to open this application? So I'll say open Postman, and once you open this, okay, so you will notice that you will be logged in. So this is taking a bit of time. Okay, so it's saying welcome to Postman and tell us a bit about yourself. So it is now onboarding us to this particular application. So now I'll say my name as embarkx official. I'll just keep it embarkx, and my role is I am, let's say, a full stack developer. I'll get started. Okay, and I'll say got it. Okay, now we'll have a history tab over here. So suddenly you will see we didn't have all these tabs. Okay, and now you can see we have tabs like collection. Okay, we have tabs like environments over here on the left hand side. You have history as well. All right, and what you can do is you can go to history. Okay, we have just added this particular request here, and you can see the save button enabled over here now after you logged in. Okay, so you can definitely save this, and it will ask you where you want to save this request. Okay, so it's telling you that you don't have any collections, and collections let you group related requests. So if you have multiple API requests that you are doing that are for a particular application, you can group them together, okay, using a collection. All right, now you can say create a collection over here because I don't have a collection, and I can name my collection. So I can say job application over here. I'll say create. Okay, and the save button is enabled now. Okay, I'll say save. So you can see this has now been saved to the collection. So this was the post request. I'll just close this. Okay, this is another post request, and I can go to the history and I can simply save the get request as well. Okay, here is a get request. So I'll save this get request and I'll save it to the collection. The collection is selected now by default. You can add a description as well if you wish to. Okay, but I won't. So I'll just get this saved. Okay, I'll save this hello application as well. So these API requests. Okay, and I'll change this. I'll create a new collection and I'll say hello world app, like so. This is saved, and I'll save the get request as well. You can save everything you need. Okay, And if you go to collections now, collections tab, you will see, so if I right click over here on the API request tab, I can close all the tabs. Okay. Now over here under collection, you will see these collections here, okay, which have been created. So these are like folder, and this does a really good job of organizing all the APIs. Okay. So you can click on this, you can have this saved. Okay. You can modify this and you can save it again. You can create a copy of this. Okay. So I can go over here as well. Click on 3 dots, duplicate this. Okay. You can duplicate this as well. So all these are the possibilities with Postman, and you should leverage these possibilities. Okay. So if something happens to Postman and if you have not signed up and if you have not saved the API request, you have to create the API request again. Okay. You need to write the JSON again. It takes time. Okay. But this is much more easier, and we have this functionality, and you can leverage this by doing a simple free sign up. All right. So this is about Postman in how you can save the API requests. So we have come very far with our application, and we are learning a lot of things slowly. All right. So I wanted to highlight and I want to talk about JSON response. Okay. So over here right now we are getting a response as hello world. Okay. If you pass something over here in the post request, you see hello Spring Boot depending on what you have passed in. All right. Now the thing is, when you're designing APIs and when you're working on real world projects, you would be working with objects, right? So Java is a object oriented programming language like we know, and Spring Boot is based on Java. So underlying technology that we are using is Java. So it is all going to be classes and objects. Now, when you're designing APIs in real world, you would be returning the JSON response. So JSON is the standard, JSON and XML, but JSON is used frequently, and JSON response is what you will be returning to whoever wants to consume. Okay, and that is what the standard is. Now over here, what we are returning is a plain text, or a string, I should say. It's hello world. How do I get JSON response over here? Okay, so we need a way wherein we have objects, classes, and we would be translating those objects and classes into JSON response with the help of the API. Okay, so let's see how we can do that. So I'll come over here to our code base, and here we have this controller setup. Now what I'm going to do is I'm going to add a class that is going to store the message. Okay, so it's going to be a very simple class which is also going to store the message, and it is going to help us understand how we work with classes and objects when building APIs. So I'll come over here. Okay, and here I will create a new class, let's say, and this class so we can call this class as, let's say, hello response. Okay, it's going to be a very simple class. Okay, like I said, and here let me add so what I'm going to do is here I'm going to add a parameter, or a class member, I should say, not parameter. I'm sorry about that. So I'll say private string, and I'm going to say message here. Okay, and I'm going to generate the corresponding getters and setters. Okay, so I'm going to go over here and I'll auto generate the getters and setters. So we have this particular class which is managing the message. Now what I'll do is here in the controller, instead of directly returning the string, okay, what I can do is I can return the object of hello response. Okay, and how will I do that? So I can say over here, so let me cut this. Okay, I'll cut this. I'll say new hello. You can see hello response here. Okay, and within hello response, I'll pass in hello world over here. Okay, and you can see this is being passed. Now here we don't have a constructor. So what I will do is I'll get a suggestion here, create a constructor. So the constructor is created. Okay, so it did not set the values automatically. So what I will do is I will come to this class. I'll say generate constructor with this one parameter, and this is it. All right. Now you can see here. Okay, so now we are getting another error that this is returning string, but we are returning hello response. So we need to change the return type over here. This is done. Okay. Now I can rerun this code. Let us see what the output looks like. Okay. So you can see the application is started. coming back to the Postman, if I trigger a GET request, you should see a JSON response here. Okay, so this structure is the JSON structure. If you want, you can even head over to the browser and you can say validate JSON, and you'll get a lot of validators. Okay, so you can go to any of the validators. They will validate whether whatever you have, whatever structure you have is a valid JSON. So I pasted this, clicked on validate, and it says it's a valid JSON. Okay, so this is a JSON response that our API has returned. Okay, now talking about the other API that we have, the post request, it is returning this, right? So I'll copy this, I'll come over here. Okay, let's minimize this. Here I'm going to say new hello response, and I'll pass this entire piece of string as the parameter for this. Okay, something like this. Okay, and this is again going to give me error. It will say make hello post return this instead of string, and I'll say yes to that. Now if I rerun, okay, you should have a JSON response here as well. So if I send this, you should see message is JSON response. Okay, you can see here message, and this message, what is this message? This is coming in from hello response. So here if you go, here you have this message. Okay, and it is, what it is doing is it is converting the object of type hello response into JSON object. So let me explain this as to how this conversion happened automatically. Okay, we did not do anything. We are just returning the object of this type, right? And the conversion into JSON happened automatically. So if you go to a REST controller here, okay, REST controller has this annotation response body, okay, which means that the data that is being returned by each method returned directly to the response body, which means that the data returned by each method over here is written directly to the response body in the appropriate format. Okay, and the conversion is internally handled by Spring, and it makes use of something called as message converters. Okay, so there's a concept of message converters which handles the conversion of values into JSON automatically. Okay, and this conversion that happened right now is being handled by something called as Jackson library. Okay, so there is no import statement for the same, but if you go to like the project structure and if you click on external libraries, okay, if you scroll up and down here, you should see Jackson. You can see some libraries having Jackson in the name. And also if you go to like the run logs over here, and if you search for Jackson, you should see over here Jackson everywhere. Okay, so this is a library that is in use. Okay, and this is handling the conversion from the object to that of JSON. Okay, so what it's doing is Jackson serializes the Java objects to JSON. So here we return the object and it is doing the job of serialization. How does it do it? It does so by calling the getters on the object for all properties. Okay, so if you see over here, we are defining the getters. Okay, so we have getter, so it is going to serialize that particular property. Now this also tells us that if we don't have a getter for this property, that property will be ultimately skipped from the response. Okay, so this is something that you need to keep in mind. Okay, and this Jackson library is something that we have not added. Okay, how did it get added? So I'll tell you that as well. So if you go to pom.xml over here, okay, and if you scroll down here, we have this dependency Spring Boot starter web. So this starter normally includes all the dependencies that is required for building and developing web applications, including the JSON handling through Jackson. Okay, so it's coming in because of this line that we have added over here. Okay, so this is how the JSON response will work, and this is how you can like get the object converted or serialized into JSON. Okay, so I hope this was useful, and I hope you have a clarity of this particular concept here. So let us now begin talking about path variables. So what is path variable? So whenever you are designing a GET request or a GET endpoint, there will be scenarios wherein you might want to pass some variables within the URL itself. Okay, and this variable will add to the dynamicity of the URL. Let me explain what I mean over here. So I'll just duplicate this endpoint here. Okay, and here I'll call this as hello param, and here I can have a dynamic parameter, and let's say based on what this variable is, okay, I will change my response. Okay, so let's say I can pass in name, and this is syntax as to how you can pass in a dynamic path variable into a URL, okay, with the help of Spring Boot. Okay, so if you come over here, okay, we have this hello API up and running. If you pass in /name, it is not going to work, right? Okay, and this is not working because we have not handled this dynamic part here. Okay, so I wish to handle this. So what I will do is I have this thing over here. Okay, I'll tell Spring Boot that, hey, this part of the URL is dynamic. Okay, and whatever is being passed over here should be given to me with the variable name called name. Okay, because name is the variable name that we have put up over here. Okay, and what I can do is whatever user is passing, I can get it over here. I can get it path variable. I can say string, and I can say name over here, something like this. Okay, and what I can do is I can even print that over here. So I can say hello, and instead of this, you can have, so I can say here, and let me get rid of this. Okay, here I can say name, like so. Okay, now let me run this. So let me run this and let me show you. Okay, so you can see the app is running, and now where we were getting an error, if I refresh, you'll see like I'm getting hello name over here. Okay, so I've passed in name over here. If I say hello John, it'll give me hello John. So whatever I'm passing over here, I'm getting that as the response. Okay, and we are doing this with the help of a dynamic variable in the URL that catches that particular variable in the method with the help of the annotation path variable. Okay, so we are making use of this annotation. Okay, now what is path variable? So if you come over here, this path variable is a annotation that is being used in Spring MVC to handle the template variables in the request URL. Okay, so it will bind the method parameter to the URI template variable over here. Okay, and this is useful if URL often contains parameters and there might be some dynamic elements into the URL. Okay, so that is what we are doing. Now, talking about the use case as to why you want to make this thing as dynamic. Okay, so there are several use cases. You might have an API wherein you might want users / and you might want to pass in the user ID over here. Okay, something like this, user ID. Okay, like this. So you might want to pass in /users/1, and that will give you the first user. Okay, so you must have seen endpoints like this if you have been doing development. If you head over to Google and if you go to any blog, so I'm here on Amazon blog, okay, business.amazon.in, and if you see any article, it will have the slug over here. Okay, let me switch over to some other article. So if I go to this article, okay, differences over here, you can see the URL remains same, just this part changes. Okay, URL is absolutely same, you can see. If I switch over to another blog, let me do that here, you can see this part changes. Okay, so in blogs, you must have seen this concept of dynamic URLs where a part of URL is dynamic. So that is being handled, or that can be handled with the help of path variables, as you can see. Okay, so you might be wanting to have these kind of URLs like to make your application SEO friendly. So in blogs, this can make your article SEO friendly, right? Like this is anyone searches for e-commerce business ideas can get this as a search result in Google. Okay, so these are some use cases, and I wanted to bring this up and explain this concept to you all. This concept of like having path variables. Okay, so I hope you have some clarity. Also, I want to mention, like, after this variable over here, you can even have one more part in the URL. So I can say show, for example. Okay, and if you come over here, let me run this. So once this is running, if you refresh this will give you an error now because it is expecting show over here. Okay, so you can see. So is show dynamic? No, it's not. Only John is dynamic. So if I change this to Michael, something like this, it will get that as a response. If I change this to Tom, you'll get that as a response. Okay. So you can see, you can have a variable in between two fixed parts. Okay. So these are two fixed parts, and in between you have this template which is telling that this part is dynamic. So that is also possible. Okay. I just wanted to showcase this to you because this is important, and when designing URLs, you will often come across this particular thing here. All right. And just be sure to have this variable name like in the URL and this name as same. Okay. So if you make this as name1, it won't work for you as expected. Okay. So this and this in the URL has to be same so that it can map to each other. Okay. So yeah, that's about path variables when it comes to creating dynamic URLs with the help of Spring Boot.